Thank you, Prasanna and team, for creating a positive and heavenly atmosphere by the beautifully rendered song. May I now request our Director Personnel, Shri Samir Mukherjee sir, to deliver the welcome address.
Good morning to all of you. It's a delight to have you with us, and special thanks to all the delegates who have traveled afar and made this come to this occasion. I appreciate taking your time off from the busy schedules to join us today. I take pride and privilege, it's my privilege to welcome you all to this launch of Nikon Plc controller and Linux-based control SCADA systems, software in collaboration with BARC and Iec and ECIL. And I'm sure this is an historic moment, a step towards self-reliance and Atmanirbhar Bharat. Such steps and collaborations will continue, and it will not be the first and the last one to be launched from ECIL, BARC and Iec together. Our team of experts have put their heart and soul and worked to come up with this solution. We are pleased to have made it worthy with your presence. We are looking forward to scale up these operations many times over. This is going to be possible only with your help and continuous support, and anticipate a long-lasting solutions towards this. While we would have loved to have our Secretary DAE and Director BARC amongst us, but I'm given to understand due to pressing assignments, they have not been able to make it, but they have graced this occasion, wonderful occasion, by delivering a recorded message, which I would like to be played now. Thank you. Josna, can you play these messages?
Namaskar to all the participants. I am very happy to learn that the Nikon PLC, jointly developed by BARC and ECIL, is being showcased today to various prospective users. BARC and ECIL have been collaborating for indigenous design, development and manufacture of a variety of complex control systems over decades. I congratulate the team members of BARC and ECIL who have worked hand in hand towards development of this new product. I would like to mention here that some user groups from DAE family have already initiated the process of induction of this PLC for testing in their respective plants, and the preliminary feedback received thus far has been quite favorable. I would like to take this opportunity to urge our colleagues from the steel, power and oil sectors to use and evaluate the Nikon system and provide us a valuable feedback. This would enable us to enhance the product and incorporate any additional features to meet their specific requirements and make the system more robust. I am hopeful that this workshop will be useful towards providing the inputs necessary to meet this purpose and make it a state-of-the-art world-class product within a short span. I also hope that the ready and reliable availability of this Indian product will prove to be of use to all the Indian technologists and will help reduce our dependence on expensive and uncertain imports from the international market. I would also like to urge the developers to speedily complete all the remaining steps to obtain the software certifications for the product. This will help in full deployment at DAE as well as at other industrial sectors. I am hopeful that collaborative efforts such as these by all of us would help India in taking a step towards in the Atmanirbhar Bharat initiative of the Honorable Prime Minister of the nation. Thank you very much and Jai Hind.
Dear colleagues, my greetings to all of you. Applications has emerged as a crucial requirement under the current scenario of increasing threats and vulnerabilities being faced by organizations. BRC has been at the forefront in the efforts of safe and secure PLC along with a Linux-based SCADA software for implementing applications with the new PLC is being launched today by ECIL and BRC. BRC and ECIL have been collaborating on many fronts over the decades for development of nuclear electronics as well as the other electronic equipment. The development of state-of-the-art PLC adds one more feather in the cap for these two premier organizations of DAE, symbolizing the spirit of cooperation nurtured over several decades. It is heartening to note that the new product has already been deployed successfully in some critical applications. I feel confident this product will meet the requirements of not only the department but also find application in various industries. The conduct of workshop to create awareness about the product is necessary to expand the user base, and the initiative taken by ECIL in this regard needs to be complemented. I take this opportunity to congratulate the scientists and engineers of the two organizations who have strived hard for the development of the product and wish the product great success. Jai Hind and thank you. Dear colleague.
Thank you, Samir Mukherjee sir, for your earnest welcome address. Thanks to K.N. Vyas sir and A.K. Mokan sir for their motivational messages.
The world is full of diamonds and gems, and we are having some of them here today to build this event. With this note, I would like to give my heartiest welcome to the esteemed dignitaries to the dais. I consider it a great honor to welcome Shri Y.S. Maya sir, ex-CMD ECIL, to grace the dais.
Srimati Anita Behre Madam, Director Electronics and Instrumentation Group from BARC, onto the dais. May I request our Director Personnel sir to accompany Madam to the dais.
It gives me immense pleasure to invite Shri Debashish Das sir, Raja Ramanna Fellow DAE, to grace the dais.
With equal pleasure, I invite Shri P.P. Marathe sir, Raja Ramanna Fellow DAE, onto the dais.
I extend a warm welcome to Shri Neeraj Agarwal sir, Executive Director, Electronics and Instrumentation, NPCIL. May we please have you on the dais, sir?
Now, I would like to invite Shri Vineet Kumar Sharma sir, Site Director from NPCIL Tarapur, onto the dais.
I would take the pleasure of inviting Shri Rajendra Kumar Gupta sir, Site Director, NPCIL Kaiga, onto the dais.
I would like to invite Shri H.R. Pimpakar, Executive Director, Design and Technology Development, Nuclear Recycle Board, onto the dais.
I humbly invite our ex-CMD, Shri P. Sudhakar sir, onto the dais.
May I now request Shri Nuni Rambabu sir, Executive Director, Nuclear Vertical, ECIL, to grace the dais.
Thank you, Madam and Sirs. Let us welcome all the dignitaries with a huge round of applause. Your aura has lent a unique charm to the occasion. Flowers symbolize prosperity, purity, and positive vibes. Before the launch, let me first acknowledge the presence of our eminent guests by presenting bouquets. I request Srimati N. Hema Malini, CRND, to present a bouquet to Shri Y.S. Maya sir.
I request Srimati Santoshi Singh, CRND, to present a bouquet to Srimati Anita Behre, Madam.
I request Srimati
Srimati Sirisha Devi, CRND, to present a bouquet to Sri P.P. Marathe, sir.
I request Srimati Komala Cat to present a bouquet to Sri Neeraj Agarwal, sir.
I request Srimati Hemalata Madam Cat to present a bouquet to Sri Vinay Kumar Sharma, sir.
I request Srimati K. Vaishali, CRND, to present a bouquet to Sri Rajendra Kumar Gupta, sir.
I request Srimati K. Komali Devi, CRND, to present a bouquet to Sri N. H.R. Vibhakar, sir.
Thank you.
I request Srimati C. Annapurna, CRND, to present a bouquet to Sri P. Sudhakar, sir.
I request Srimati L. Vijayeshwari, Lady Representative, Staff and Workers Union, to present a bouquet to our Chairman and Managing Director, sir.
I request Srimati P. Raghavi Soumya, Lady Representative, Iec Officers Association, to present a bouquet to our Director Personal, sir.
I request Srimati Sheetal Cat to present a bouquet to our leading nuclear, Sri N. Rambabu, sir.
May I now request our Chairman and Managing Director, Rear Admiral Sanjay Chobe, retired, to address the gathering.
Guests, ladies and gentlemen, our veterans who have made this event possible. I see them in large numbers. Some of them I can recognize here. Very happy to see you all, and a very warm welcome to ECIL. It is a proud privilege for all of us to welcome you here on this very historic moment. Why do I say that as a historic moment is because there has been a passionate effort put in by large number of people, some of them whom you see on the dais, some of them whom you will listen to over the next 2 days, who have made this possible. It is not easy. In the strategic sector, one of the important components, what you see here, we have successfully deployed in some of the most critical installations of the country. It is no mean feat. This journey will continue, and therefore your participation, especially our esteemed guests who are here from various sectors, we sincerely look forward to your support and your feedback so that we can develop a product which truly and totally meets your aspirations. The idea is only one: make this nation Atmanirbhar. Too much dependence has happened over the last 7.5 decades, ever since we have achieved independence. It's time we stop that. Over the course of next 3 days, there will be invited talks by people who have gone through this journey. They will share their experience. They will also showcase why this safe and secure product is very important in all our critical installations. I'm sure you will enjoy listening to them, and also request you to provide your views and feedback on how we can further improve, because this is a continuous journey. Improvement is part of life. We sincerely look forward to your participation in further improving this product, and also invite you to take some time off and see this wonderful city of Hyderabad, though the weather is not very inviting. So while you go back enriched with a product that will meet your aspirations, you will also carry good memories of this wonderful city. Thank you very much. We will continue to interact over the course of next 3 days. I wish this workshop all the success, and certainly look forward to some takeaway points that we would like to continue working on and improving this product further. Thank you. Jai Hind.
Dignitaries on the dais and ECL officials, a very good morning. It's really very heartening to see large number of delegates participating in this workshop, and I appreciate the efforts of ECIL in bringing all of them together here to deliberate on the safety and security issues related to the industrial automation systems. The industrial control systems used to be proprietary and standalone systems. But the technological advances that have been made, particularly in the computer and communication fields, become more feature-rich systems with the incorporation of those developments. Ironically, the very same technologies which have enabled the industrial systems to be more efficient and feature-rich, they have also contributed for the vulnerabilities systems through malware or otherwise. The IT world certainly has come up with a lot of tools and techniques to prevent, detect, and even address these vulnerabilities, and to some extent mitigate these vulnerabilities. However, the very specific nature of the industrial control systems, like they need to work round the clock with deterministic response times, make these tools and techniques difficult to directly incorporate for the industrial systems. Added to this, the recent trends, sophistication, and even the dedicated approach of some of these intrusions made the things much worse. The well-known Stuxnet is a very good example of this. I'm sure this workshop will deliberate definitely all the issues concerning the safety and security of the industrial automation systems, and also the countermeasures that are required to deal with ever-growing threat. ECIL has come a long way from giving the country's first programmable logic controller to the introduction of the new one in close association with BRC and Iec. I am having one observation with the ECIL-made systems. While technically they are best on par with the systems available in the market, sometimes non-compliances, like not able to meet to a certain international standard, renders them not useful for some specific applications. I believe that our Department of Atomic Energy has got well-established ecosystem for qualifying the systems for mission-critical applications. And I'm sure this ecosystem can very well be considered to overcome some of these difficulties. I'm very happy to note that organizations like ISRO and some other DAE organizations have already set the trend and started using the new product. I wish the new product and the workshop a great success. Thank you very much.
Thank you, sir. We are charmed by your remarkable speech. Certainly, your address goes a long way in inspiring us to work for the need of the hour and contribute significantly to the organization and to the country. May I now request Shri H.R. Pimpadkar, sir, Executive Director, Design and Technology Development, Nuclear Recycle Board, to speak a few words.
Respected dignitaries on the dais, ladies and gentlemen, first of all, thanks for inviting me for this function. I am really got very happy, and see this development of this Nikon PLC is really a need of the nuclear need for our nuclear program, and from user side I'm happy that we are going to use this PLC for our upcoming projects. I know what kind of difficulties we are facing when we are using the PLCs from different agencies, and then over a period of time what kind of difficulties we are facing. So definitely this program, development program, and the efforts which has been put from ECIL community as well as our DAE colleagues, BARC, Nuclear Recycle Board, and Iec definitely will bring this product to the at par. I will say that not only at par, but we can make much better, and we can use it for our programs in large way. I wish all the best, and all the best for launching of this program, launching of this product, and wish all the success for this workshop. Thank you.
Thank you very much, sir, for all your compliments and warm wishes. May I now request Shri Rajendra Kumar Gupta, sir, Site Director, NPCIL Kaiga, to convey his message on this occasion.
CL, CMD, Rear Admiral Sanjay Chaube, and other dignitaries on the dais, senior officials from other organization. Good morning, all of you. As we all know, that ECIL is a multi-product, multi-discipline organization, and number of product initially they developed for the nuclear, space, defense, and other organization. We can say that ECIL is a perfect example of Atmanirbhar. ECIL today also one product, this Nikon PLC and e-SCADA is now developed, is a one more step towards the Atmanirbhar Bharat. I wish for success this product. This is to be today it is to be launched. Thank you.
Thank you, sir. Your words definitely boost our spirits and fervor to raise to a global stature. May I now request Shri Vineet Kumar Sharma, sir, Site Director, NPCIL Tarapur, to address the gathering.
Thank you, ma'am. Chairman and CMD ECIL, Mr. Sanjay Kumar Chaube, dignitaries on the dais, and the participants for this workshop from all the industries, ladies and gentlemen, a very good morning to you all. Indeed, it has been an honor to be present over here, I would say, amongst the galaxy of present and past ECIL CMDs, I would say. I believe 3 ex-CMDs are here and present CMD, Mr. Chaube. It's really been an honor, and that too on an occasion which marks India's self-reliance and Atmanirbharta, the launch of this Nikon PLC and e-SCADA system. At least because I being from the field, from the day I joined, I've been working with C&I systems, and I know the requirement of such a product, how much it was needed. Because as long as my memory goes, initially when we were just SOC or D and handling the C&I systems, that time we had a PLC, we were struck, that too, ECIL also among their systems, for EMTR system, they have supplied a PLC. That was, I believe, Siemens 100 S4. Then we had, for DGs, we had Allen Bradley PLCs. The trouble with these things were there that once they are supplied, later on for doing any modification, anything, and OEM support, it was so difficult to get through these things. When the things ease out, then with the imported PLCs and systems, the problem came that the CLND clause came in between. It was very difficult to get these systems for a small, if you want to upgrade any PLC, it was at site level, it was becoming very, very difficult. I'm glad to overcome all these difficulties. DAE, a true DAE product for DAE utilities have been developed, and it will go in a long way to cater for our requirement, including strategic requirements. As EDNRB has just pointed out, there also I heard that for their INRP project, this product is being deployed. Similarly, for NPC also in the coming years, probably in a long way, this PLC will be deployed and it will be beneficial for the country and organizations. As Mr. Sudhakar was pointing out, the issue of vulnerability and security is a big challenge nowadays, because maintaining a system in a secure and manner is day by day becoming difficult, and once you have other imported systems, handling that OEM with these all in the gamut of the security atmosphere is a very difficult challenge. But with ECIL and DAE, ECIL being a DAE unit itself, that issue also we'll be able to amicably address at the sites. So definitely it will be a very beneficial product for us, and ECIL has been known for its support which it provides for its customers. We being at NPCIL definitely rely on ECIL too much, and ECIL also, they walk a mile further in supporting our units. I'm thankful for that for ECIL. And with the launch of this product and the sessions which are going to be conducted, I hope the participants will be participating, they will gain full advantage of that, and it will be helpful at a later day in all the organizations, whichever they represent, whenever these products will be deployed there. Thank you. I wish the program and the workshop which is going to commence a very success. Thank you all.
Thank you, sir, for your inspiring words. We'll definitely strive hard in future also to move in a progressive manner. May I now request Shri Neeraj Agarwal, sir, ED, E&I, NPCIL, to deliver his speech.
Thank you, madam. Respected Shri Chaubeji, Shri Y.S. Maiya, he was my mentor. He has taught me in my training school. Mr. Sudhakar, Mr. Devashish Das, and other dignitaries sitting on the dais. I can see a lot of intellectual people sitting here. I'm very sure next 2-3 days, they'll put a lot of energy and a lot of enthusiasm to understand the new system. Actually, I'm very happy to be present during the product launch of Nikon PLC and the Linux-based SCADA actually. Actually, it is a very right time, you know. India is celebrating 75 years of independence. Our PM is talking about Atmanirbhar Bharat. And we are looking for a product which we can use in nuclear industry, where we don't have embargo, we have a long-term support, and we know the inside out. This is a perfect time for ECIL to launch this product actually. We are very happy to know. As you know, in our NPC, in one unit of NPC, we use around 158 IO nodes. That consists of a large number of DCS nodes. Around 53 PLCs we use in one unit. And they are used in safety application, safety critical application, and non-safety application also. And we were looking for a product which are very safe and secure, which meets our cyber security requirements. And you know, with the incidents which happened in Siemens, Stuckness, all of us are aware. And some recent incidents also is happening actually. Something happened a couple of weeks ago. Some attack was there in the power grid in a European country. So with these kind of things actually, a product which is made in-house, which is cyber secure, and regarding their supply side management is also good. I think you will have a very good component management. The possibility of Trojan is not there. So definitely we will be thinking of using this thing in our future upcoming projects. Along with that, we have some few more requirements which we are going to put in our KAGA projects. I thought a lot of knowledgeable people are there. Let us put our NPCI requirement henceforth. See, now we are looking in KAGA for a remote IO, because you know, in our projects, a lot of cabling we are able to see. And cabling is getting it doesn't give a good look. So we are looking for a remote IO kind of thing. And already in our Kakrapara 3 and 4, in non-nuclear systems, we already put a smart instruments. which is connected via Profibus to our PLCs which you are buying from outside. Maybe in the next phase, ECL and ECL can look for that. ECL and BRC can definitely look to develop that thing actually, because that will be, you see, basically when we say that we are going to use PLCs, actually why I should use PLC? See, a basic advantage in today's world, we are talking about Internet of Things, Industry 4.0. When we have such kind of good systems, we are getting a lot of data. What we are doing with the data? Have we thought about that? See, will I be able to reduce one shutdown of my plant, or can I increase the availability of my plant? Let us think on those lines. A lot of data we are going to collect with these smart systems. How we can use the data to go for a proactive maintenance. See, that is the direction we should think. Now we should say that, okay, this PLC we have made is good. Now let us go to the next step actually. See, already in NPC, in Kakrapa 3.4 also, we are use some systems which will be able to tell us, okay, this is a trend my process is taking, and this is a possibility that system may fail after 6 months, let us go for maintenance. These kind of things we have already used in our non-nuclear systems. We can use this in nuclear system only if we get a support from BRC, we get a support from ECL, because there we need a system which is fully VNV is done. We see the inside of the system, which in a commercial system, they will not be willing to show us. So if we get that, we will be very, very good. A very small request with ECL. Definitely, your systems are good quality. We are using your system from last so many years. ECL and BRC have supported us from very beginning. Can we make deliveries in time? Can we reduce our cost? And what about long-term support and obsolescence management? These are the things which concern us. Our earlier speaker from PCA also told about this. When we get imported PLCs, they supply us because they give a very good competitive price. And being a government sector, we have to go for L1. We buy from them, then getting a long-term support becomes sometimes difficult to us. So can we work out a mechanism jointly with ECL? How can, as we saw 53 PLCs we are going to use in one unit, and now 10 units of our 700 megawatt is on the line. And definitely our light water reactor also, a lot of units are coming. KK 3, 4, 5, 6 are already there. Can we think of a way so that you can supply us in a good competitive price and have a long-term support? If those kind of things are worked out, that will be win-win for all of us. Like we have a very good talent here, we have a very good product here. Why we should not use it? I think these are the questions we should dwell upon. And our team from NPCL is there. Next 2-3 years, I think you will be speaking about, you means the people who have made this PLC, they will be speaking about the features of the system. And our team is here to evaluate it and understand it and see how we can use it in our system. I'm very sure it will be useful to them. It will be useful to ECL also. I wish a great success to ECL on their Nikon PLC. And definitely we look forward to use these Nikon PLCs in the near future. And in the long-term future, definitely whatever requirements I have told, our good team from ECL and BRC and Iec maybe do work something on that. Thank you.
Thank you, sir. Thank you for your appreciation and valuable feedback for improvement, which allows us to march forward in a unique way towards a glorious future. May I now request Shri P.P. Marathe, sir, who holds Raja Ramanna Fellowship in DAE, to address the gathering.
Respected dignitaries on the dais, Chaube Sahab, Maya sir, and all my seniors and colleagues, and also respected, I will say, audience, because they are customers, so they should be respected, for giving future orders. Now the question just now Neeraj ji posted, I think I will have some answers to that, and also will convey to other colleagues which are from other sectors. Just background to this is, it's a really long journey. Let me congratulate a team of BRC experts. Within DAE, also Iec of course, the long-lasting efforts made by ECL team to bring it to such a level. So it's a journey of decades. Started with TPLC and BRC, subsequently today turning into a product as Nikon PLC. And it has matured over a period of time, like especially the features which are incorporated and taking care of stuckness problem to the today's requirement from ERB, especially the guidelines which are for cyber security and various security aspects. Knowing all these requirements, DAE has taken up a project whereby setting up various facilities at ECL, and they were important from the point of view that any customer, when he wants to deploy a system, so before deployment, it should get tested to his requirements, as well as he should be able to demonstrate, not just on the PC with simulator, but if it is actual hardware, if we have a platform, we can port it and also check for the perfect performance requirements. Knowing that a very good setup, 32-node system, it will get discussed during the workshop, is set up at ECL. And in fact, whatever Mr. Pimperkar told about their requirement, one of the important overall system is actually simulated, and validation of thereby the entire hardware architecture as well as the software is done on that platform. In addition, customer also they are interested in knowing how they are getting qualified. So we have set up as a part of the, again, DAE program, whatever the inadequacies were there, like we did not have all the EMIMC requirements, then aging requirements, HALT and HAS, as well as nowadays even strategic industry partners, they insist for ESS requirements, that is environmental stress screening. So all such setups are available in-house. In addition to that, also maybe replying to Neeraj's question, that delivery time. Yes, ECL has gone at EMSD, especially dedicated automated lines, whereby your production time can be really brought down. And it can be dedicated specifically for such applications. So that also came through our DAE part of the project. And all such, knowing the requirements of future, DAE has taken care, which was initiated by Maya Sab as an initial project coordinator. And in last 7 to 8 years, we could complete major requirements which would be required for our DAE family. And also it will cater for industry. So one of the problems which normally ECL faces, I will pose from CMD side, that how to bag the finally order. So many times what is happening in industry, suppose an indentor, I just go to the market and try to meet some few vendors, take their catalogs, maybe a Schneider catalog or ABB catalog or something, and I make my specifications, making those inputs, taking those inputs. But naturally, when we are having an indigenous product, we are having all those requirements, performance point of view, or even overall hardware meeting. But certain certifications which are there, which normally European industry insists, like CE certifications or various other, they are right now not there, but subsequently it will be incorporated. So what is more important is you take care while making the specifications, since our Atmanirbhar product is going to be launched. So the industry partners, I would request that you look at the specification and don't just simply copy, which are Schneider or any other industry, but take the specifications what we are now will be, ECL, will be projecting in next 2 days workshop. And you will try to understand that how robust and how the best incorporation has happened, finally inculcating into this particular product. Now, you will listen to more speakers, and subsequently in the 2 days workshop, a lot of more deliberations, technical deliberations will take place, and all to your queries, they also would be answered. So I take this opportunity once again to congratulate all the team members, design team from BRC, ECL, as well as now for customers to know and clarify your doubts, and wish this product launch a great success. Thank you very much.
Thank you very much, sir, for your quite informative and enlightening words. May I now request Shri Debashish Das, sir, Raja Ramanna Fellow, DAE, to speak a few words.
Rear Admiral Sri Sanjay Chaube, CNMD ECIL, Sri Y.S. Maya, and all distinguished dignitaries present on the dais, senior delegates to this workshop, represented not only from DAE fraternity and also from other sectors, ECIL, participants from ECIL, DAE, and all our ladies and gentlemen, a very good morning. In fact, I consider this occasion that I am fortunate to be part of this rare occasion where so many CNI experts, users, and also the customers and users of CNI systems to be present here. I consider that maturing of safe and secure Nikon series PLC as reaching significant milestone for the system developers of CNI in the country. Nikon has been developed by synergizing the efforts of DAE R&D community, mainly BRC and IGCAR, along with ECIL. The maturity in development of CNI systems in ENI community of DAE, BRC in particular, lies in the fact that the community has been delivering all CNI requirements for DAE programs from designing to commissioning, including long-term technological support since the inception of atomic energy. I mean, it dates back way back to 1956. And in every such developments by DAE R&D centers, the ECIL has been an integral part in engineering, manufacturing, qualification, supply, and providing long-term customer support. In last few decades, ECIL has established every qualification infrastructure that is required to qualify the CNI systems under one roof, and the quality culture of manufacturing nuclear gate CNI systems has been instilled since decades. To be precise, it is the need for having a CNI technology manufacturing establishment that fully complies to building nuclear gate CNI systems had brought ECIL into existence 5.5 decades ago. And the umbilical cord with DAE R&D labs strongly fuel that technological strength to ECIL till date, and it will continue. The Nikon development has been conceived at ECIL, integrating many developments that has taken place in BRC and IGCAR, including the design developed for NPC over the years to cater to build not only a safe CNI architecture, but also to incorporate features to address the ever-growing threat perception to critical digital asset security. CNI systems of safety functions in nuclear installations has been an integral part of the design and well adopted in all installations of DAE. The present Nikon addresses the security concerns of building the features that assures security with provisions for continuous update and upgradation. I'm sure Nikon will aptly fit the requirements of many CNI systems in other sectors, for example, oil, energy, steel, transport, etc. In the present rapidly evolving global scenario of IP-based systems for high-end technologies, the complete technologies in entirety has rarely been owned by a single entity. The complete technology rests on complex supply chain, which is vulnerable to disruptions, especially at demanding times. In my understanding, it is in this context the relevance of homegrown Nikon PLC stands distinctly in long-term sustenance of E&I ecosystem for critical digital assets in the country for all stakeholders. ECIL is well poised to serve the nation in this endeavor, and I urge the developers of all CNI systems to have in-depth assessment of Nikon for adaptation as long-term CNI system technology solution. With this, I wish that all your interaction for next 2 days are highly fruitful and wish you all success. Thank you so much.
Thank you, sir, for your wonderful speech, which highlights the worth and impact of fundamental research, manufacturing, and cutting-edge technologies bolstering ECIL's contribution in the development of Nikon PLC and SCADA. May I now request Srimati Anita Behre Madam, Director, Electronics and Instrumentation, BARC, to convey her valuable message.
CMD ECIL for organizing this event to bring together all who are concerned with the development of Nikon PLC. The people who had the vision, who initiated, shaped, encouraged this development, the development team, as well as the people who are going to be the end users of this product. So this event has brought all of them together. I also thank him for inviting me as chief guest. I am honored to share this occasion with my seniors, Shri Maya, Shri Das, and Shri Marathe, along with other dignitaries from NPCIL and IGCAR, other DA family also. So, sir, as all of us know, today's age of digital technology, these PLCs are the workhorse of process control and automation applications. So they offer the robust, modular, flexible, and reusable platform with ease of programming. But most of these PLC platforms are all of foreign origin, and they have their own problems. There can be end user restriction, or sometimes lifetime support may not be available, or mid-life technology denials may be there. Also in recent past, there has been target of cyber attacks. Already these points have been touched upon by other speakers. So these issues were being addressed by different DAE units on a case-to-case basis. So this is a first-of-a-kind initiative to bring together all the design and qualification, certification expertise of BARC, IGCAR, ECIL together, and developed a robust platform as an indigenous product. So this has been a very successful exercise and resulting in today's product launch. So I compliment all those associated with this development for their dedicated efforts, and mainly is a collaborative, big collaborative effort was required for this development. So another thing, this is a good thing which has happened is that there is a reference system available on which for application software development, which some your application itself can be demonstrated. So it gives a big confidence to the end user of what is possible for testing, validation, and demonstration of proof of concept of application can be implemented on the large size distributed control system. Another good thing to know is that already one system has been deployed at ISRO for a time critical application. So it shows that this platform can be customized for specific applications. So this is, I know it's a big achievement, but there is still a lot of things to go ahead. Maybe some, main thing is the certification, already Marathe Saab has mentioned. So also this standardizing that platform across DA's units will go a long way in establishing its viability as a good product. So this technical program for next 2 days will help the participants to understand all these features, its viability in deploying in safety critical, time critical, and other process control applications, and provide the developers with good feedback. I once again congratulate the design team for achieving this remarkable milestone, and I wish them great success for this product as well as for future further progress in this program. Actually, this wish is for more progress in this direction is for all of us, that we all will benefit from this achievement. So with this, I thank you all. Thank you, sir.
Thank you, Madam, for giving us a clear insight into the details of milestones achieved in the development of PLC and SCADA.
We would now have the keynote address delivered by Shri Y.S. Maya Sir, ex-CMD ECIL, the main driving force behind the development of indigenous PLC. He has been instrumental in synergizing BARC, ECIL, and IGCAR in the development of PLC. Please welcome.
Good morning, friends. Very nice to be back with you after 2 years of embargo. We had something like embargo. Let me start with noting the extraordinary coincidence of today, having this function today. I don't know if any of you remember. Maybe Vishwanath and Prakash Sir should remember. It's exactly this day, 10 years back, we launched the predecessor of this PLC, 18th May 2012, and Dr. Anil Kakodkar came here and set in motion evolution of a product whose mature stage we do today. So my first suggestion, of course, is to remember this date, 18th May, by having every year, customer meetings or developer meetings for PLC, like other PLC manufacturers do. I think that's a thing we should do. Once in a year, call all the customers, developers, and take the thing forward. Because it seems to be that 18th May is a very good date. In fact, I'm finding even the time is coinciding. Exactly at 11 o'clock, Kakodkar Sahab had cut the ribbon for the PLC. So maybe CMD Sahab did not know that it's a coincidence. I was going through the photographs and I was struck by the date. So this is a long journey. The products of this kind do not happen overnight. So I want on this occasion to remember the great men who had put in motion, this evolution of PLCs in ECIL. Goes all the way back to 70s. It was, Kasaragod and Kanitkar who built the first PLCs in those days where there were not even microprocessors, based on core memory, battery-backed memory. PLCs were built in line with what is happening in the rest of the world. Just like in so other fields, computers, television, micro equipments, antennas, ECL pioneered even PLCs in India. They went on to supply these PLCs for critical sectors in oil, gas. In fact, some of the first PLC, I think, went to the oil sector itself. That's what I read in the biography. And then PLCs also got integrated into the nuclear sector. Because nuclear sector, for others who are not in the nuclear sector to know, is that introduction of computers is always a very difficult activity. It involves tremendous amount of analysis, verification, validation, reviews. So a factor of assurance for other industry about this PLC is that it is being introduced into the nuclear sector itself. So these pioneering efforts of the 70s in ECIL continued into the 90s when NPCL was building a fleet of reactors, And then there was a need to, there was a possibility of introducing PLCs in a large way. And that is where I got involved in the development of PLCs or ECL's PLCs from BARC. So we, team along with the ECL's team. I don't know if any of those people are there now in ECIL, unlikely. So I was involved in building the network support for, token bus networks for integrating the PLCs of ECIL. I remember, working in your, maybe it is CAD 3 buildings, innumerable cup of tea, midnight, and free supply of upmas by ECIL. So we have worked, days and nights in those days to build those PLCs, which went on to, into the reactors at Kaiga in Rajasthan. Those days, it was, I think, Kanaya, Prabhakar, Narsingh Rao, Arifuddin, who is no more with us today, Rangarao. These were the people who were there at CAD. I worked along with them. Then came this, what's called modified Projecon, Projecon 2012 launch in 2012, which ECL could, using this, penetrate into ISRO, NRB, BRC markets. It was still, a long way to go in terms of qualifications, and that is where it was felt important to involve BRC in a deeper way in getting into nuclear qualifications for the software. So that was when I was in ECIL, and then I was fortunate to have people like Prakash Rao, Kannaya, Meenakshi Sundaram. We worked together. They're the people who really led from the front to realize what I was pushing them to do. And we could come out with an industrial strength PLC which looked and felt like a PLC. Customers are used to a particular feeling of what a PLC should look like, not only physically, but even when you start using them, engineering them along with them. So while our earlier PLCs were looking like standard computer PCBs, and they were not enormously very rugged and things like that. So this 2012 effort resulted in the culmination of a PLC which looked like a. So I thank and congratulate those teams which could realize those things, and today we are, benefiting from those early work. And then, of course, the synergy which happened between BRC, ECL, IGCAR, and NPCIL in, going through entire revision of the hardware architecture and the software architecture so as to make it compatible with the nuclear industry qualification requirements, what's called the D25 standard. So that was another major effort, and the Reactor Control Division team led by Vaidya and the ECL team, which continued to be there for, they worked together, and then the NPCIL team along with IGCAR, we could achieve a lot of convergence in terms of hardware, in terms of interfaces, in terms of the SCADA software, which would sit as major milestones in what we are celebrating today. It was clear even by the 2009-10, around that period, that security is going to be an equally important concern for an automation workhorse like a programmable logic controller, which is going to be at the bottom of every critical industrial infrastructure of any country, whether it is power grids, whether it is trains, whether it is steel mills, whether it's oil and gas sector, petrochemicals, airports, nuclear reactors. They're all going to deploy programmable logic controllers, and they're going at the heart of it. while it was always understood that the safety depends on these things, the security was a new dimension that one could easily penetrate into the software of these PLCs and maliciously change them, either data or the software code, and then cause mischief. The mischief could be loss of availability, mischief could be make equipment failure, plant failures. And we already read about Stuxnet, and you know about grid failures in US, and so it's an ongoing thing, it's going to only increase. So this is one of the important platforms on which nations also need to have their own safe and secure PLC. Concern was that, and so in our effort in architecturing these PLC, we try to accommodate those concerns, build in design features which would help us to provide certain assurance of security. 100% assurance is not possible always technically. It could be a combination of technical and administrative measures, but then the very fact that it is being designed within India by a reputed public sector undertaking, the life cycle management is being entirely done in India, is a first important step in providing the assurance. It is not a final step or a complete step, but it's an important step. And the other issues of life cycle management of the product, including maintenance, operation, etc. So today we can say with some confidence that we are achieved partly that promises which we made for ourselves. And on the safety front, of course, there was this effort to align with the D25 standards, which I believe is fairly well on, and also to align with the SIL standard, what's called safety integrity levels, which in the industry uses to benchmark PLCs of various safety categories, from SIL 1 to SIL 4, to get even a SIL certification for this PLC, so that when you go through tenders, you are able to satisfy the SIL requirements. Let me assure all of you that we know every bit and every byte and every piece of code which runs on this PLC. We means our Indian engineers and technicians know, and we know every piece of circuit which is there, which is all designed in-house, and that means it can be repaired. We are not dependent on others to achieve all this. So this BRC's involvement in PLC development was, it also goes back quite a long, many years back. But first major initiative happened when the TPLC, the Trombe PLC was launched and announced, and some work went on. But they were going in a bit on parallel directions. The TPLC work was not going aligned with the ECL's development, and one of the things which it did was to bring about a convergence. So today we have two product streams, I understand. One which is meant for specifically for the nuclear industry, the reprocessing plants and the reactors and things like that, which complies with the D25 standard software. D25 requires that every line of code has to be reviewed and available for review, etc., etc., and that required an ab initio development of the entire development framework itself, ourselves. So the development engine itself is in-house developed. And there is another version which ECL is building on top of commercially available development platforms, supporting all the 5 IEC compatible standards for programming PLCs, the structured test and the function block diagrams and the sequential flow charts and the ladders and all that. So there is a menu there. There is something you can choose from depending upon the safety concern and safety needs of the plant. Of course, a single shoe doesn't fit all in PLC market. PLC market also is diversified, as you know. There's a dimension of safety. PLC is meant only for hazardous plants, explosive areas, or petrochemical plants like that, where safety is a major concern, or PLCs which are not very safety critical. So that is where the SEAL standard came up to classify PLCs as for the safety requirements of a plant. There is a dimension of geographical distribution, whether it is all concentrated in one place or whether you require PLC to import a remote I/O. So these are another dimension of a PLC put from few dozens to thousands of I/Os. Scalable in terms of performance, few milliseconds of cycle times or sometimes even microseconds. But then these teams which were built today jointly, ECL, BRC, is equipped to build within the country work. Other dimension is the safety, that's the fault tolerance dimension, where you need to have dual redundant or triple redundant or quadruple redundant, multiple redundant configurations. Agency all in one house and together. Controller, even though the name has stuck, it is much more than a programmable logic controller alone, which also does analog control, recipe control. It does trending, logging, all kinds of things. So integration of loops, there's the PID loops integrating with multiple workstations, multiple PCs. And the SCADA package, which again is a convergence of many. Some effort was made to bring them into a common platform, so that the user is not confused and there is a advantage of standardization. So today this PLC can integrate third-party SCADA as well. It is not necessary that you should only use our SCADA, but you can also use SCADAs you're comfortable with, because the protocols are, again, interoperability is there, standardization is there. And you can use any PC as a user interface, desktop PCs. And one more constraint we put on ourselves is to go open source software. So these are all based on Linux now. But more work has to be done. There's a continuously evolving field. At one side, ECL will be now productizing and pushing them into applications, but evolution is a continuous game, continuously should go on. So we must work on IoT technologies and integrating more field buses, and of course including even wireless for certain industries may be important. Safety industry normally has concerns, but so these are the directions on which work has to progress. Now coming back to penetrating the market, making yourself wanted by the customers, and how to fill those gaps between having a product and finally selling it. Cost would be a primary differentiator. I think we need to be highly cost competitive, and we need to, of course, having delivery times almost like off the shelf. So it will be a good idea to have off the shelf delivery as a target, or not more than a month. If somebody wants to evaluate a PLC, I should have it ready-made. And a design engineering support, which is required to be very strong, to work along with the customer to provide engineering support. So it is not just selling a PLC. ECL will not be only selling a PLC, they'll be selling automation solutions. So that is their strength. They bring together 3 divisions within ECL itself: a corporate R&D, which does the basic R&D, a control instrumentation division, which does the engineering, and a control automation division which does the manufacturing, quality manufacturing. So they have all kind of capabilities within these sheds. Quality documentation supported by videos and YouTubes, and certainly use all modern technologies to proliferate, make it aware, make customers aware of your products. Regular training programs and training materials must work on. I'm sure you have a lot of it, but then a good quality training will be essential to make this product successful and stand in good stead with respect to competitors. And of course, a business model where you can, rope in channel partners or system integrators. In a medium-term basis, one has to think about it. Right now, you are in the early stages, but eventually, if it has to enter into other industries, it may not be possible for ECL alone to do all the marketing. So you need to have. That's what happened in the beginning itself. In 70s, 80s, ECL had a fairly good this kind of models, but you have to open up some of this way of doing business. And of course, O&M support ECL are always good. You have nationwide presence. And walk the talk on the security aspects, so that you have O&M support, security audits of your systems, trails of how many security violation attempts happen. So security audits including penetration testing. So differentiate your product with respect to others. That is something which will certainly gain more informed customers in the critical infrastructure segment. That is what we should be aiming for. People who are in the critical infrastructure segment, whether it's in the railways or power sector or in the petrochemicals industry, etc., etc. In terms of expanding the capability of the PLC, in addition to process control market, we should also look into motion control segment, discrete manufacturing segment, which is already there, and possibly industrial drives and automotive in the future, because these will come in a big way. In fact, as of all of you know that India is being positioned as the global manufacturing hub. There is a major thrust by the government to make India a manufacturing hub with some 30% of GDP to be, got from manufacturing in the near future. I think it was 20% by 2022. There was a target some time back. So this means a lot of industries coming up in India, and this means an opportunity for PLCs. That's what globally they are looking at Southeast Asia as a major market for PLCs. In fact, it is said that the global market is something to $12 to $15 billion per annum for PLCs, and Indian market maybe $100 to $200 million per year. So even if we capture a tenth of that market, it is enough to sustain a division. May not be possible only within DAE, but already CNID had a good penetration into other sectors. But important to keep the customers coming back to you, happy and coming back to you. I have no doubt that these teams have the capability, the will, the endurance to make this happen. I'm also happy to see that successive managements of ECIL have encouraged this work. Since my days, all the CMDs are sitting here, they all have pushed this activity to a level which has made us reach here today. And this reference system is a very good proof of the pudding, where you can see that working systems where the new logic can be demonstrated, it can be implemented quickly and demonstrated. So funding has also come generously from DAE to make this happen, and funding will continue to come if you have plans. So you need to have visions going to the next decade to work on differentiating areas where the product can be further differentiated, all those bells and whistles, which are also important to make a product. When somebody makes an RFP, you always look for those features which are all available in the internet, and you should not be found lacking in having those features. But then that is left to the R&D guys. Separate out the project from the R&D and have a plan every year, a project release, etc., etc. So every year on 18th May or thereabout, I have a meeting of customers and all that. It's a good day, looks like. So my hearty congratulations to all the teams from ECIL, BRC, NPCL, IGCAR for working together. Working together is the mantra. That is the key strength. My congratulations and thanks to also customers from other sectors who have reposed faith in ECIL, have seen the long-term benefit of being with the partner, an enduring partner like ECIL, which doesn't abandon you halfway and which doesn't blackmail you, because you are now in an oxygen, deathbed. So that kind of thing, at least these companies don't do. That, as a friend from NRB mentioned, all of us have gone through this. NPCL has gone through this, NRB has gone through this. We all know the difficulties of maintaining systems for long term and falling into temptations and then getting into problems. But then you cannot be, you cannot keep whining, or you cannot only depend upon that. Finally, the quality of the product and the quality of the services only have to deliver. Today, there's a technology foundation, a product has come. So let me wish all the best for this product. We have named it Nikon. This Namakaran also happened sometime, some years back, I think. So marrying the nuclear pedigree with the con pedigree of ECIL, so Project Con, and then it became a Nikon. So I wish Nikon will prosper, and you will have 1,000, 2,000, 3,000, 4,000, whatever series coming up. So wish you all the best, and wish you all the best for the workshop, which is there for the next 3 days. So a lot of technical stuff and a lot of evidence that a lot of work has gone into building this PLC. I hope that it is you go home with a good feeling and a confidence, and come back to ECIL and demand from ECIL the services and quality which you expect. So once again, thanks for the organizers to remembering me and making me come here after 2 years. It's always a pleasure to be here along with all of you. Nice to see all of you here. Thank you very much, and good day.
Thank you very much, sir, for sharing us the important milestones of the majestic journey of evolution of PLC and SCADA, and also for elaborating the applications of PLC and SCADA.
Today is the big day. To think of how far-flung we have come and how afar we still have to go, along with multifarious struggles and triumphs. There is much more to thrive and much more to show. Let's rejoice this majestic journey. Now, we have the most awaited moment. We take pride in launching the grand Nikon Programmable Logic Controller and Linux-based supervisory control and data acquisition system software.
I request our Chairman and Managing Director, Rear Admiral Sanjay Chaubey, sir, to guide the dignitaries to do the honors of the spectacular launch.
Thank you, sir.
Thank you, Madam and Sirs, for doing the honors.
Everything is controlled by PLC. Display also. Display started by one of the digital output. Here digital is different type. You have program in the remote access.
That is actually
this is output. This is output.
This is your RIO. Can be anything.
Like this 32
panel is
hours.
also there, but it is right now hidden by this. There is an alarm panel.
Everything is curtain raising is coming done with this one.
We'll take you separately. No. You are not in my space.
Already there, no?
Hiya, madam. I'd like to have a photograph with all of you. Hiya, sir. Please. Maya, sir. Maya, please.
నువ్వు తీసుకుంటే నేను
యాక్చువల్గా రైట్ సౌండ్లో అయిపోయింది.
అందరూ అవుట్లేదు
వస్తున్నాను ఇంకా యాడ్ అవుతున్నాను. సార్ ప్లీజ్ కమ్ సార్. వన్ మినిట్
కిరణ్ వీడియో తీసుకుంటా. ఓకే వెయిట్ కెమెరాలు తీయద్దు. వెయిట్ సార్. నో వెయిట్
Mohit Kalra, Prem Kumar, can you join? Bera from the audience. Mohit, Prem Kumar, please come for the photograph. Gauri Shankar.
Once again, a huge round of applause, please.
Head CR&D. Gopal.
కిరణ్ పిచ్ వెనక. కిరణ్ నేను ఇంకెళ్ళిపోతా.
We find exquisite delight in felicitating our honored guests. I request our Chairman and Managing Director, Rear Admiral Sanjay Chaubey, retired, to felicitate our honorable dignitaries with shawl and mementos.
May I call upon Srimati Anita Behre Madam, Director, Electronics and Instrumentation Group, BARC, for the presentation. Thank you, Madam, for humbly accepting our reverence and affection. I request Shri Devasis Das Sir, Raja Ramana Fellow DAE, to accept the presentation.
What happened, man? What's going on?
I now request Shri Vice Maya Sir, ex-CMD ECIL, to accept our token of affection and reverence. I request Shri P.P. Marathe Sir, Raja Ramana Fellow DAE, to accept the honor. May I now request Shri Neeraj Agarwal Sir, Executive Director, Electronics and Instrumentation, NPCIL, to come forward to accept our present. I now request Shri Meet Kumar Sharma Sir, Site Director, NPCIL Tarapur, to accept the honor. May I now request Shri Rajendra Kumar Gupta Sir, Site Director, NPCIL Kaiga, to accept the honor.
ఎందుకంత ముందు పెడతావు కెమెరా
I would request Shri H.R. Pimpalkar Sir, Executive Director, Design and Technology Development, Nuclear Recycling Board, to accept our present. Executive Director, UPF, Shri N. Rambabu sir, to propose the vote of thanks.
Thank you, Lisa. Good morning to all. Honorable Sri Y.S. Maya sir, respected Madam Anita Banerjee, distinguished guests on the dais, Sri Devashish Das sir, Sri Marathe sir, Neeraj Agarwal ji, V.K. Sharma ji, R.K. Gupta ji, Anil Thakur ji, Sri T. Sudhakar, and below the dais, I would like to respect Madam Anuradha ji, then Rajiv ji and Vaidya ji and our CMD and Director Personnel. It's my privilege to propose the vote of thanks on this occasion. Actually, today is the auspicious day. I want to announce this, but Maya Sahib has already announced that we have done one launch exactly 10 years before. So I thought nobody will remember, but Maya Sahib, by heart, he knows the in and out, and he has announced. And sir, as you said, we will try to celebrate. This is a PLC day in ECIL. Sir. First and foremost, I would like to appreciate ECIL management for their kind approval for this, celebrating this occasion. And now I will come to that. I thank to the Secretary DIE and Director BRC for sending their kind messages to all the audience for this function. Definitely, sir, as suggested, as guided by Secretary Sahib, we will finish and speed up all the formalities required for the qualification of the product, and we will bring it to the market with full-fledged certificate that in a short time of maybe 6 months. On behalf of ECIL, let me call the fraternity of DAE and other key organizations of the country here together, extend very hearty vote of thanks to all the dignitaries and the guests for gracing this occasion and sharing your views and opinions about ECIL PLC. Sir, a big thank to Mr. Maya sir for not only his keynote address, he was the man behind this program and for this today's function also, because as a CMD, ECIL, he united BRC, IGCAR and ECIL for developing a common platform for the PLC so that entire fraternity can use the safe and secure Nikon PLC. I also extend my gratitude to BRC and IGCAR management for giving continuous support during the development of PLCs. Sir, as you said, we will do this, we will celebrate this, and the SIL certification, we are already in the process of obtaining SIL certification, and shortly we may get, we have already floated the tender, and we are going to get the certification, sir. I must mention our deep sense of appreciation for Srimati Anita Behre Madam for her continuous support from BRC. Also, I am grateful to Sri Devashish Das sir, our beloved ex-CMD, for his continuous feedback even after he left ECIL. Even he used to guide us, he used to tell the requirements for the PLC, for RRCAT requirements, he has communicated many times, and he is continuously was giving the feedback to CR&D team. Sir, coming to Sri Marathe Sahib, we know him is, rather than a BRC person, he is mostly known as ECIL person, posted at BRC. And most of the questions posted by Neeraj Agarwal Sahib is answered by Maya Sahib. He has eased out my job. So, sir, definitely we will, whatever you said, we will meet the requirements. Sir, I may like to express our sincere thanks to Sri Neeraj Agarwal Sahib, Sri V.K. Sharma ji, Sri R.K. Gupta ji, for coming all the way to ECIL from their busy schedules and gracing the occasion. The Neeraj Agarwal sir, as you said, the delivery, cost and long-term support. Yes, sir. We will, on this, we will promise you that we are competent with the market and deliver in the shortest period. Now, if today is possible, we will show all the facilities to you, and from that you can estimate, you can judge the capabilities of ECIL. And for the cost-wise, we are ready with the equal partners like BHEL, or we are ready to compete with them. Sir, I'm also grateful to see HR Pimparkat, sir, from NRB, coming all the way and gracing this occasion. And sir, we are all inspired and motivated by your great words, and we will adopt all guidance provided by you. We also would like to acknowledge our gratitude to Sri Vaidya sir, and Anuradha madam, and Rajiv sir, and Bera sir, for continuously educating and enriching our teams to the tune to the requirement of qualification and product. Qualification of the product, sir. Mr. Vaidya is, even though we are not following, but during even COVID pandemic, he used to follow from Mumbai to our team. Evening 5 o'clock, any phone call comes, our people, nobody was there to touch that phone because they know that will be from Mr. Vaidya ji. The way he was chasing them to brought this product. And I am very much thankful to Anuradha madam and Rajiv sir for the qualification process they have adopted for this verification and validation. And coming to that, my sincere thanks to all the guests from BRC, NPCIL, NRB, NFC, IG Car, Heavy Water Board, RRCAT, UCIL, RMP Mysore, ISRO, IPRC, IOCL, HPCL, BPCL, BHEL, NTPC, SAIL, Rosatom, Electronet, and I may be missing some more, but we are all thankful, all of you, for coming to this occasion. And before conclusion, let me thank my colleagues from various departments, OEM members, staff and workers union representatives who supported me wholeheartedly for conducting this program. I also thank NFC management for extending this auditorium facility for conducting this event. Sir, after this lunch, after this high tea break, the program will continue for a further couple of days. Enjoy the program and provide your valuable feedback on the product. Once again, thanks to all. Jai Hind.
There is a feedback form placed in the bags presented to the delegates from various organizations. We request you to give your valuable feedback on the event and hand over the forms to our representatives. Our representatives will come and collect the forms from you. We shall all now move for high tea. I request all the dignitaries to move to the lounge located behind the stage for high tea. It has been arranged towards the right side exit of this auditorium for all the delegates from various organizations and employees of ECIL. Thank you.
Belongs to you. You can meet the customer's aspirations or requirements in the least possible time, which may not be possible if you have imported the item. So that is the key point that we must take care of. And as you will see in this testimony, ECIL is not only making a product and giving it, it is actually developing the product with the customer. So you are also an owner of the product. That is the point that I want to highlight. And of course, at the end of this, I'll again come back to you after you have seen our facilities. I just wanted to once again reassure you that every point that was spoken in the morning has been well thought of. We have taken care of it. And we want to partner the further development and production to meet your aspirations. Can we have the video message, please?
Real Admiral retired Sanjay Chaubey, ex-CMD Y.S. Maya, ex-CMD P. Sudhakar, ex-CMD Debashis Das, other distinguished guests on the dais, senior officials and delegates from various government organizations, research institutes, central and state PSUs, and ladies and gentlemen. Good morning. It gives me a great pleasure to greet you all through virtual mode during the inaugural session of the product launch, Safe and Secure PLC and Linux SCADA, jointly developed by Electronics Corporation of India Limited and Baba Atomic Research Center. We at ISRO Propulsion Complex Mahendragiri are responsible for assembly, integration and testing of liquid propulsion systems for launch vehicles as well as spacecraft projects of Indian Space Research Organization. To accomplish the test objectives with the highest degree of safety and reliability, programmable logic controllers are used as control system to achieve fast response, more deterministic control, as well as hard real-time control. At present, various PLC systems imported from different manufacturers are being employed at different facilities in IPRC. To achieve self-reliance in this strategic technological sector, IPRC intended to promote development of indigenous systems and induct them in all its test facilities in a phased manner. With this objective, firstly, an indigenous M-Progicon 5200 PLC system manufactured by ECIL Hyderabad was installed and interfaced with IPRC in-house developed iSCADA in standalone control configuration with cycle time of 50 milliseconds, and this system is performing quite satisfactorily in one of our test facilities since 2017. In 2018, IPRC further initiated action for indigenous development and supply of hard standby PLC with 10 millisecond cycle time for 3 more test facilities to test yet storable and cryogenic engines for our launch vehicle as well as spacecraft application. The system requirement for these facilities was most challenging with a deterministic cycle time of 10 milliseconds and switchover from main to standby within 2 cycles in case of failure of the main. With respect to this requirement, Nikon PLC systems with completely new CPU were developed by ECIL, handling channels ranging from 1020 to 2040. During the development period, intensive interactions were held at regular intervals between IPRC and ECIL, and all technical issues were resolved related to hardware and software development. ECIL team showed remarkable zeal and vision and developed the systems fulfilling all intended requirements in a consistent manner. The PLC systems thus developed had been tested at ECIL with the redundant hard standby configuration rigorously as per the detailed test procedure document jointly developed by IPRC and ECIL. Subsequently, the site acceptance tests were also carried out successfully in the redundant configuration as per operational requirements on all 3 PLC systems at IPRC. I am happy to inform this August gathering that presently all the 3 PLC systems are quite satisfactorily working, meeting our control requirements in full. Technically, newly developed Nikon PLC systems are at par with any other commercial PLC systems available globally in the industry, and this indigenous PLC system offers all technical features available with any other PLC vendors. Foreseeing the future requirement, we have initiated discussions with ECIL to develop advanced PLC systems, and we are planning to induct them in a phased manner in all our test facilities. Implementation of indigenous control systems in all the test facilities at IPRC will enable us to achieve deployment of secure control system in our strategic areas. Also, it provides reliable and uninterrupted hardware and software service during their operations. Indeed, this great technological feat was realized jointly by ECIL and IPRC and will enable our nation to achieve self-reliance in other strategic sectors also. It opens up many new opportunities to address our future technological challenges. Ladies and gentlemen, it gives me immense pleasure to greet and wish a grand successful event over next 3 days on this occasion of product launch, Safe and Secure PLC with Linux SCADA. Thank you, one and all.
Well, the message was quite informative and motivating indeed. Knowledge is power. Information is liberating. The secret of change is to focus all your energy not only on fighting the old, but also building the new. Knowledge drives innovation. Innovation drives productivity, and productivity drives economic growth.
With this, let us move on to the technical presentations and workshop session of our program to share the details about the features, customizations, and the future scope of Nikon PLC and SCADA. On that note, let me take the privilege of inviting Shri Uday W. Vaidya Sir, Head RC&D from BARC, to deliver a presentation on Indigenous Secure PLC program.
Yeah. It is plugged in. It is not there. Am I audible? Yeah. So I'll be covering the overall perspective of secure PLC design, and the other design team members will drive you through further details, because covering all things, I'll just put the points and based on that they will take things further. The agenda of my presentation is, I'll just briefly cover in line with what Maya Sahab has said, what is C&F NPP, how programmable platform enters in NPC in nuclear power plants, ultimately how commercial PLCs also found some inroads, and then what we need is security by design, safety we are aware of, and then I will give overview of Nikon PLC design, and rest will be followed by the other design team members. Just try to tell you what is the characteristics of digital INC in NPP. These are all custom-built designs. They are designed by domain experts. They are designed for safety. There are no COTS. And security by design doesn't come because these are benign systems not connected to network. So these issues were not seen at all. And then these designs, all these custom-built C&I system designs for research reactors and power reactors evolved at BRC, IGCAR, NPCIL, and as a part of ecosystem, ECIL was responsible for manufacturing, installation, and commissioning. So ECIL was managing designs from, or is managing designs from BRC, IGCAR, NPCIL, ECIL own designs. So all such designs, they need enormous efforts in development, IV&V, regulatory clearances, because ultimately safety of the reactor matters. When you have to have so many designs of variety of designers, long-term maintenance of variety of designs come with its own issues. You have to maintain components for variety of designs. A lot of inventory is blocked. One of the biggest issues with these custom-built designs is that very large turnaround time for requirement change request. After the system is delivered to the plant, and when some requirement change is there, particularly in a safety or safety-related system, it has to follow the entire life cycle as per the regulatory process. So design has to be done, it has to be validated, you need some kind of test platform for that, and then after V&V, you have to approach the regulator and then clear it. So it's a long time. These things came because over a period of time, with the advancements of technology, the embedded system started becoming complex, and that's why requirement change management became difficult. Now, solution to this, if you see world over in NPP, like if you see KKNPP or if you see French designs, they have a lot of configurable platforms. We can't call them as like equivalent to IEC 61313 PLC, but they were, I would say, PLC for NPCIL, some PLC for NPP. I mean, they are giving a lot of programmable features. So we also followed the same trend, and it led to configurable designs. I mean, we had developed programmable, configurable systems, and networking features also evolved, leading to our own custom PLCs. Again, not PLCs like Maya Sahab also mentioned. So some of the examples of these PLCs, I mean, EC Logic, eSCADA, UCAX, Progicon, mProgicon, TPLC. Also, with the advancement of digital technology, we started using advanced processors, we started using programmable devices, we started using a lot of networking, a lot of system interconnections. So though we got a lot of benefit out of it, ultimately it led to security issues, because a lot of interconnections, those things were not thought, and then you find that security is also getting impacted because of this. At the same time, at this juncture, many PLCs, commercial PLCs, they were deployed in NINS type of systems because of the advantages of these PLCs seen in the other commercial industry. I mean, PLCs, their automation workhorse, modular hardware, reusable design, graphical programming. And this leads to application development by process engineer. You don't need any person with a expertise in C++ or C or assembly and write the code. It's only all graphical programming, function block ladders. So whatever your logic, you program them in that. ease of verification. Because it's a graphical language, you can very easily verify that your requirements are properly depicted in the graphical language. It drastically reduces the development time. You can develop the application maybe in 2 weeks' time or 1 month's time. And change requirements again very easy, because most of this PLC development environment, they provide you some kind of simulation on the engineering console itself. So where you check your logic concern, transparency and visibility means that the firmware of the PLC, the basic firmware of the PLC, you can't subject to events. It's a black box for us. Cyber attacks is also, there are several examples quoted by the speakers during the inaugural session. And then it becomes very difficult to trust these PLCs if we want to put them in our critical applications. So in a nutshell, if I say commercial PLCs, fine, a lot of PLCs are there, but they come with issues of they being of foreign origin, there are induced restrictions, design transfer issues are there, halfway they will go run away, so technology denials, cyber attacks, and we can't trust them. So this is where, as our mentor Maya Saab, he has driven us that instead of going for parallel developments at BRC, ECIL, and then IGCAR also was planning, NPCL was planning some way, it is a good time to join hands and build a product which is not only meeting the requirements of safety, but also addressing the issues of security. And that conceived that is the birth of Nikon. So Nikon is nothing but consolidation of exercises, consolidation of design expertise at BRC, ECIL, IGCAR, and we have now. So what are the consolidations? What we have done? TPLC platform complying to ARB and SG25 IC 60880 standard. That drove us first of its kind, giving industrial look, industrial packaging, so having all standard VME type of boards. So this comes something from things already done. So we thought that when you have to build Nikon, it should meet the safety class IAIB requirements of NPP. That means it has to meet D25 requirements. It has to meet it should also for the team. Design objectives for us. So consideration of security requirement right from the design stage. This was for upcoming and future DA for position the product at engineer's wish list. Maya Saab has mentioned. Sir, we are already planned, and it will be seen during the presentations by the design team members. Now, as we say, we have to see, safety we are well aware of, but when we say security, a security analysis, pre-analysis before we go for design is an important activity. So as a part of this, we carried out analysis, what all things are required, what are the threats, what are the impacts, or what are the protection measures we should have. So we had seen what are the possible, what are the variety of threats and vulnerabilities, unauthorized modifications, embedded software, firmwares of the programmable devices, process configuration, process parameter configuration, and this is what action, backdoors, OS key points which were considered when we are looking at the design of the Nikon from the security point of view. So based on this, we worked out security requirements for communication interfaces, security requirements for development environment, a very important thing, security requirement for PLC firmware from security point of view, and physical security and access control requirements. So when it comes to requirements of communication requirements, see, we should segregate control, communications, SCADA functions separately. No, the CPU, the main CPU should not do all these things. So try to segregate and then build some kinds of firewalls or some kind of interfaces between the interfaces to see that the travel of any attack vectors will not reach the main CPU. Go for robust communication protocols. While we design the systems based on secure PLC, employ features like hardwired data diodes, secure gateways, so on. I'll just quickly go to the other requirements. Firmware requirements like restricted control flow and data flow, guard against vulnerabilities like buffer and stack overflow, which can happen because of malicious attacks. go for a small footprint, real-time, robust, hardened kernel so that there are no backdoors and you get a embedded, deterministic performance. Go have runtime integrity checks and diagnostic checks. They are also coming as a part of the safety. Guard against unexpected command sequence, a very important thing that needs to be going to the design. And independent verification and authenticity and integrity of the PLC firmware at boot time and runtime. Another important aspect of this PLC, which I will briefly tell you how it is implemented. Physical access controls, I'll go through very quickly. Wire break detection or module being duplicated, counterfeits and all that. So such kinds of things we have added. Development environment. We must use tested and proven development tools. Also, there has to be strict access control. All the documents should be always password protected. So isolation of the development environment from internet, very critical requirements, and we are religiously following that. Periodic scanning and vulnerabilities and threats, and access log. So with this, and the guidelines, design measures normally we follow for security is that go for a flash memory based designs for storing of the application software, PLC firmware, physical access control, two-factor authentication for critical parameter modification, defensive network programming. So, you should not accept any connection request for anyone just like that. A lot of techniques are available for that. Implement those things. Go for a small footprint kernel, I already mentioned it. Network monitoring, and then you should have features for detection and isolation of the faults. Salient design features, I am just displaying here, but my colleagues will present that in detail subsequently. Salient designs of hardware features, both these PPTs will be covered in detail in the subsequent presentations. Now, one of the USP of this design is called System Security Board. So this has a lot of security features. So like one of the things is secured application downloading. If I have to download the application on the PLC, it has to be first enabled from here. If I have to, then it also authenticates the system software independently at runtime. It also authenticates application software at runtime. Secured modification of critical parameters. Again, this is a unique feature. Like many times you say that from SCADA, I should be able to change the set points. Now, if some critical set points are modified from SCADA in a malicious manner, it will go unnoticed. So all such critical set points, access is allowed only after you have a access control enabled from this secure peer, from this board. So on this board, you see there is a keypad and display. So from this keypad and display, you have to enter the password, enable the things. There is the access control switch also. And then only the parameter change will be enabled. And if this mode is enabled, it also generates an output which can be used as alarm in the control room to indicate that this feature has been enabled. And if you are not taking action within some specified time, it will automatically disable. So there is no way a malicious command coming from SCADA can modify the set point, and which can lead to any kind of disastrous actions which happen somewhere in foreign countries. Again, it has got watchdog has to be independent functionality. This provides the watchdog also. In case it detects unattested software, it halts with a fail-safe output, and handling of system inputs and outputs for alarms and all that. These are again features on this. So this is one of the USP of this design. This is just a snapshot of board, various boards we have developed. See, all the prototyping, there are 2 or 3 levels of prototyping we have done, and variety of qualifications for EMI, EMC, environmental, everything has been done on the prototypes, and then only we have gone for the production release. Even the software functions were tested many times like FIT. FIT is a very simple thing. But what happens, FIT works in the lab or during design time, but when you go into the plant, the signals are coming 100 meters, 200 meters apart. So that cable capacitance make your FIT fail. So while we design, when we design these boards, we actually tested the prototypes with 200, 300 meters of long cables and see that no, it will not falter when it goes to the plant. Just one of the case. Like that, many more things, thorough testing was done as a part of prototype development. Now, as Maya Saab mentioned, we have come out with 2 product lines. One is Nikon 2000 series. So there's a unified hardware now, unified Nikon PLC hardware. On this 2000 series is based on indigenous software, which is a precursor to this is a TPLC. ESAS, RTOS, again it's our own in-house developed real-time kernel, 0 backdoors, I would like to proudly say. And for NPP and strategy applications, this series can be used. There are further variants which will be covered in the subsequent lectures by the other design team members. Then there is Nikon 1000 series. This is based on Codesys ID, which is a well-proven thing. All M-Progicon 5000 watt IPSC director also mentioned. Those were based on that. That one was based on VxWorks, but now here we have gone on RT Linux. So again, we have eliminated one imported components out of it. And this is on the unified hardware. So development process. The moment we say that we have to design a product, which we will like, which would get definitely ERB certification now because of our experience, past experience. And TPLC again, the first of its kind, which was qualified for as per D25. So we have followed the same development process here. Systematically controlled and well-documented development process based on HGD25 and IEC 60880. As of now, there are 140 design documents. They have been prepared, and it spans across 20,000 pages. And this has been reviewed by the independent IVNV committee, which Anuradha will be talking in her talk. Embedded real-time system software development will be as per 60880 guidelines. We are using Mishra C subset for all the system software programming, again to build in safety and security by design. Then in the Nikon 2000, which is for NPP or critical applications, now in addition to function block, we are also giving ladder. And if you see, even the IEC 611313 also says that if you need to go for SIL 3 or SIL 4, you should go for only these 2 languages, because structure text, sequential function charts, they include a lot of complexities, whereas in case of function block diagrams and ladder, the flow is always left to right. And in the 1000 series, we are giving all the 5 languages of IEC. So platform verification and validation is being carried out by independent team. And also, a large size application specific evaluation has been done by independent team very successfully. Mr. Raju will be talking on that. Very detailed talk he will be giving you. So in a nutshell, if you see, today we have a Nikon PLC, systematic development process, deterministic performance. It's a modular, scalable. The design is highly scalable. Also, because it's our indigenous design, 100% software is ours, except for Codesys. Any specific customization requirements of all the customers, current customers, new customers, can be done very easily, because we own the 100% code, we own the 100% IP of this. Robust diagnostics, fail-safe design, a lot of fault-tolerant features, security, cycle time estimation. You can estimate the cycle time in advance. You need not buy the hardware. You just develop your application on the development environment. It will tell you how much time it will take to execute. That feature is also there. There is memory protection and rigorous IVNV. So this in total make the product really certifiable. And then what one of the designer will be presenting is that how we'll be able to migrate for the certification of SIL from the documentation we have done for D25. So he will try to show you the mapping of D25 process to SIL process, so which will make the SIL qualification relatively simple. I'll just try to mention about this facility. See, Nikon PLC, we developed, I think 2019, the first stable version was ready. And INRP is really, they are courageous. I would say CE, NRB, and then they said, as we'll go it. But then any end user, first time the product is developed, how he will have that confidence that really this will going to work or not. And there, with the guidance of Marade Saab and Devashish Das Saab, they approved and they appreciated this approach to set up this facility at ECIL. So as a part of this 12 plan project, we set up a facility at ECIL. Again, we got a lot of input from NRB that how should be the configuration. So we went for a facility with 32 nodes and 9 nodes, because NRB needs across the PLC systems also, they need, see this is control system block 1, this control system block 2. Control system block 1 itself is a 32 node system. So we have built this facility, and this facility over a period of last 2 years, it has been on round the clock. You can say, I mean, it has seen burn-in test for more than 2 years. All the teething problems have been resolved. And this facility is, yes, it has proven, Raju himself will speak on that. But then I would like to tell the audience that this is a facility available at ECIL. All the prospective customers, you know, they can always approach ECIL, CNID, CR&D teams, and they can, if they have such requirements, I mean, on this facility, you can very quickly see that, yes, whether this PLC can meet. So this facility has a lot of advantages which you can harness. Also, we are using, there's a plan to use this facility as a cyber security test bed. We'll be conducting as a part of cyber security analysis. Some things we have done at a micro level, but creating attacks, creating DOS attacks, all those things, again, this facility will be used for that. These are some glimpses of the facility setup. These are the RIO nodes. These are the SCADA stations, a simulated control room there. And in the end, I would like to say that, see, secure PLC is one major component. But if I need a total integrated solution, we have to start right from the sensor to the SCADA. So SCADA, indigenous Linux-based SCADA that has been developed, and again, the designers will be talking on that. But what you need more is that servers. See, when you have servers and workstations, these are all bought-out items. And they come with some kind of boot code on that, and then we really do not know how secure they are. So we have a solution called Anunishta, which secures the servers and workstation. Again, there will be a talk on this by one of my colleagues. And it will be, Anunishta is known in DAE, but for non-DAE, it will be a very good thing. And I expect a lot of feedback from you on this about usage. Linux-based SCADA I already mentioned. We have a secure network switch, again developed jointly with ECIL, BRC and ECIL and IIT Mumbai. We have secure NTP servers. Now, if you see all the distributed systems in INC, we have to synchronize all the nodes. And then nowadays the standard is NTP, Network Time Protocol. Again, Network Time Protocol is based on broadcast messages, and then it is a one way of vulnerability where through this broadcast there could be possibility of DOS attack. So we have developed indigenous NTP server also. NPCL already, I mean, we are discussing in NPCL for that. It has been put in Dhruva. And hardware data diversity, another important thing. When we have to see that flow of information from lower class to higher class, so these kinds of, so this in general, what I'm trying to say is that along with secure PLC, which is the heart, but then from top to bottom, from sensor to SCADA, we are in a position to give a total secure solution. And this is the need of our for the critical installations of the nation. So with this, I close my talk. And see, it's a big teamwork. It's a big teamwork. So, I mean, acknowledgements are due to all the design team members from BRC, ECIL, IGCAR, Director E&IG, CNRB particularly for, choosing this and then for their upcoming project, Director E&IG, IGCAR, CMD, ECIL. Again, this development of secure PLC was funded by Technology Development Council. And I think in the upcoming TDC meeting, probably we can tell that the product has reached such heights. And then that is something what TDC expects, that what is the return on investment. So probably now we can project that what kind of ROI we'll be getting from this. And immense things goes, nothing to mention. I don't know how to say that. But the kind of support we got from Maya sir, when you have to join, collaborate, initially there's a big resistance, and that resistance has to be broken. And I mean, that was his effort.
and his guidance and his encouragement that led us to this stage today. Sudhakar was always there right from the day I know him, and while he was CMD, and subsequently also his encouragement was there when Dasab, when he took as head RCND and then CMD ECIL. The secure PLC facility setting up was again because of him, and Marathe Sahab has also given continuous support and encouragement for this work. So with this, I conclude. Thank you very much for your attention. If there are questions, probably we can, because we are already late, I'm leaving it to the, we can have in there. Yeah.
Thank you very much, sir. As a token of appreciation for his time and valuable contribution, may I call upon our chief guest, Srimati Anita Behre Madam, Director ENI BARC, to kindly present a memento Shri Uday Vaidya Sir, Head RCND BARC.
Yeah. Okay.
Respected dignitaries, I am audible. Sri Chaube Sahab, Maya Sahab, Marathe Sahab, Das Sahab, and Behre Madam, and all my friends and colleagues from DAE, BRC and BCL, and all the participants in this workshop. Good afternoon. I am Rajiv from Nuclear Recycle Board, part of Baba Atomic Research Center. I am giving a presentation on basically independent evaluation of Nikon PLC platform. I think Sri Vaidya Sahab had already explained what are the development carried out and the brief details of the Nikon PLC platform. And since we were looking for a PLC for our projects, we had taken the chance of evaluating this platform. And basically, Nuclear Recycle Board is designing and designing, construction and operation of nuclear recycle facilities of spent fuel reprocessing and waste management for DAE. And NRB basically has got a number of operating plants in Tarapur and Kalpakam. And CNI system of these plants, basically based on a computerized data acquisition control system with the PLC and SCADA. Till now, whatever the operating plants we have, the PLCs are from Schneider, mainly Quantum family or Premium. And SCADA is basically Wonderware or the Cytect. And till now, since our plants have some embargo issues and we cannot give an end user certificate, mainly availability of any other PLC or the SCADA software was not possible. Schneider used to give, but still we face some problem due to this end user requirement as a technical support after the installation or commissioning. And we are trying to manage with some open protocol systems and all till now. And here NRB now is executing a project at Tarapur. It's called Integrated Project. It has got a number of radiochemical plants, utilities and services. And each plant will be operated by a computerized data acquisition system. We call it CDAX for each plant or a process streams. And each system has got a redundant SCADA servers with redundant communication with PLC and operating stations, redundant PLC CPUs with redundant communication with RTU units and SCADA servers. Basically, we had to implement redundancy at 3 different network levels for RIO LAN, control LAN, and supervisor LAN. And it has planned to implement with dual ring fiber optic networks. And redundant inter-PLC LAN is being implemented between individual PLC system for implementing the process interlocks across the blocks. Total around 18 numbers of control systems currently planned, which will be connected across through fiber network and covering around 25 blocks. 25 blocks means it is 25 buildings. And this is a typical block diagram for one of the plant. From bottom we can say it is a plant areas. There are process parameters and field devices which will be connected to the PLC RTUs. And this here the RTU units are nodes are connected through again ring network. They are connected to PLC CPUs with a redundant network. Then further to, so here it is called RIO LAN, and the connectivity between PLC CPUs and SCADA. It is control LAN, again redundant, and further connected to operating stations of the SCADA. This is a typical system of one plant. And here I try to give a brief idea about the connectivity between the multiple plants of integrated project. There are approximately around 18 plants. So each plant has got a system of the previous screen, and all are connected through ring network at different levels, PLC LAN, control LAN, as well as supervisor LAN. And our requirement for IOs are PLC IOs, it varies from around 2,000 to around 8,000, maximum 8,000. And this particular project, we have a requirement of around 50,000 IOs in total. And currently operating plants, we have IOs of approximately around 5 to 6,000. And here I am trying to explain basically whatever the requirement of NRB for this particular project, because unless we generate the requirement specifications, we will not be able to evaluate. So I am trying to just give a brief idea about what are the specification requirement. And low parameter accuracy is around 1%. Update time of SCADA 1 second. Normally our process is comparatively slow, so we are able to accommodate with this specification. And maximum time to execute the command is 3 seconds. And changeover of any SCADA server, primary to standby, it should be less than 10 seconds, but without a loss of any data. And in case of failure of the active PLC CPU, the standby CPU should take over in a seamless way without affecting any planned operations or the monitoring of the data. And extensive system diagnostics are required up to module and channel level. And security implementation is required. And primary storage capacity for 6 months and secondary storage for 5 years. That is mainly the SCADA requirement, because future analysis of the process data will be required. And here I am trying to give the PLC functional requirement. The system architecture is with hot standby redundant CPUs with USB or Ethernet communication ports for the programming purpose, and redundant communication for communication with RIO and SCADA. Number of IOs for one system, maximum it is around 25,000. Even though we are trying to limit the IOs per block, it is around 8,000 because of the performance requirement. Type of IO, digital input, digital output, analog input, analog output. electromagnetic relay output, solid state relay output, and PID functions should be supported. Programming language, ladder, FBD, SFC, compliant to basically IEC standards. And CPU power supply input is only 230 volt AC. Hot standby requirements are for PLC CPUs, then communication modules, power supplies. This communication module, that means at different levels, already I explained to you. Maximum distance between, here actually we have a requirement of, when we have redundant CPUs, it should be located at different areas to take care of the single failure criteria. So maximum distance between the hot standby CPUs, we are expecting around 2000 meters. Number of total RTU nodes, it is 32. Communication ports are for SCADA communication as well as RIO communication. And communication protocol with the SCADA, Modbus TCP. And the PLC should have communication ports for communicating with other field instruments like Modbus TCP or even serial. Then PLC to PLC communication for interlocks and sharing through inter-PLC LAN. This is very much important because even this integrated project is having a number of process blocks. The processes are interconnected, and interlocking of the process means PLCs is very much important. The process means there should not be any loss of data or any operation failures. So this inter-PLC LAN is implemented here. Normally earlier PLCs, actually the PLC interlock we used to implement through the control LAN. Since there are a lot of other instruments are coming in the control LAN, we planned a dedicated inter-PLC LAN for networking of the PLCs. And a network time protocol synchronization with the GPS master clock. And scan time, what we expect is around 100 millisecond maximum with 6000 IO system. And should have fail-safe outputs. Analog as well as digital should fail in a safe state in case of a failure of any channel or the module. In addition to that, single failures at different levels is taken care of already. Multiple failures, like a multiple failure of PLC CPU or SCADA server or network. In such cases also the output should fail in a safe condition. These are the typical parameter requirement for modules. Analog input 10 millisecond for 16 channels, accuracy is 0.1% and resolution is 16-bit. Analog output update time is 10 millisecond and analog output accuracy is 0.4% and input output update time is approximately around 2 to 5 millisecond. PID block implementation, we are expecting around 100 PID loops minimum. And we have a very specific requirement of pulse output, that is for operating the pulsing for the process columns. There the timing is like a 10 to 120 cycle per minute, and we have to adjust duty cycle as well as frequency. But the thing is, the output frequency or the duty cycle should not depend upon the cycle time. So, and the output will be operated by normally the solid state relays. These are the normal programming features required for the PLC, all data acquisition and processing, then engineering conversion, alarm and trip, interlock logic, operation sequence, all libraries, watchdog timer, then all the mathematical capabilities. Then CPU capacities, we expect is maximum DIO is 10,000 each, and analog input is 2,000, and analog output 1,000. And basically the functional requirement, it should be of a modular design, hot swappable, and it should be easy to remove basically the modules, any faulty modules. Power supply should be modular and redundant, so it can be replaced without affecting the functioning of the system. Offline and online test facilities, diagnostics are required. And we expect a use of proven and widely used components which are easily available in the market but of industrial grade. And system shall not have any jumpers. It should be software configurable to avoid any errors by intentionally or non-intentionally. And a proper identification labels for the hardware items. Ease of access for replacement of all the hardwares. Then troubleshooting aids like indicators, test points, offline and online diagnostic. These are the typical requirement, but this is not the last. There is a PLC requirement specification document we had prepared. I include only few points. And based on this, actually, NRB has started the evaluation of different make and model of PLC and SCADA system based on our past experience, which can meet our project requirement. At the same time, BRC, ECL and Iec had successfully developed the safe and secure PLC, Nikon. And there was a test facility established at ECIL, which can take care of the application development, testing and evaluation of the entire platform for a distributor control system. And this was implemented as a part of 12th plan project of DAE, Department of Atomic Energy. And the testbed consists of 32 block and 9 block nodes. This as per the requirement of NRB plans only. And some of the slides or the points may be repetition of what are presented by. And the same testbed can be used for performance evaluation of all the important parameters like cycle time and switchover time, system response time, etc. for all large INC applications. And this is a testbed for evaluation of safety features, cyber security and reliability. And this testbed actually, which we can use to demonstrate our indigenous capability to comply with all the technical specification of various C&I system of upcoming or future projects. And the same testbed can be used by any other organization, whether it is a government organization or a private organization, to meet the requirement, which will help other customers also. This is a reference facility for application development and application change management and associate testing and validation before deployment of application at the plant site. So, as a result, actually, we decided to utilize this facility for the evaluation of Nikon platform to see the suitability of the same system for our application. This is a typical architecture of the 32 node and 9 node test setup. There are 2 independent PLCs which are connected at inter-PLC level and supervisor LAN level with ring coupling. It is 100% simulator to take care of the verification and evaluation of the system. The checklist mainly includes physical verification, functional testing of individual modules, each and every modules, then integrated testing of this PLC along with the SCADA system, and performance testing, different parameters, type testing of the module, burn-in test, and functional testing of the program software. The section A, that is a test for verification of catalog specifications. This includes physical verification. That means basically the GA drawings, dimensions, the layout of the components, labels, connectors, or overall fitting. Everything is verified. Then each module like DA, DO, analog input, analog output, and pulse output modules have been. Then rack power supply, RIO communication modules, CPU modules, SSB modules, and network and inter-PLC modules, backplane. We prepared what are the checklist for testing each and every modules. Now, tests for IO modules are basically the functional check, response time, fail-safe output, hot support features, diagnostic indicators, and security features and power supply voltage variation test. This is not complete basically. There's a large list of tests and with different expected parameters prepared. And accuracy check, resolution check, calibration check, scan time, and module failure detection check for respective modules. And for power supply modules, it is voltage regulation test, output voltage, and current rating, short circuit protection, power supply redundancy check. Then CPU modules, we have done a very extensive testing of CPU module. This is a list of mainly configuration and features, hot restart, cold restart, hot standby, link function, communication port, memory capacity, program or run, startup function, application loading and execution in different conditions, data transfer from primary to standby, online diagnostics, and NBT protocol check. These are verification of logics or performance specifications. All configurable functions of the PLC system, logic blocks, then I/O configuration of each node, I/O driver logic, different cases of application downloading from engine console, then communication functions of RIO and SCADA network and in the PLC communication. And here performance specification like cycle time, something may be repetitive, just I'm telling. Performance monitoring of each network, synchronization, and maximum network loading in different communication network, maximum data processing load, and the performance specification degraded condition. Degraded condition means actually one or multiple failure of maybe RIO nodes or a communication networks. In such a condition also, what is the performance we specified to ensure that actually single failures also will not affect the system performance. And system diagnostics up to all the CPU levels, RIO modules and network modules, then channel level diagnostics, communication network, and testing of the safety functions and security functions. This diagnostics and all tested basically, see here we used EC SCADA as the front end for testing. So all this diagnostics information was linked to the SCADA for a display. And the test for verification of fault tolerance. We have done an extensive fault tolerance check. One is redundancy as well as fault tolerance. So here verification of PLC switch over time on multiple failures of different components, either PLC or the network or different modules. Then it was done for the failure of standby CPU, primary CPU, and each RIO rack or each module, on failure of the sync link between the CPU, and effect of each and every switch, single switch or multiple switches, and link failures. Then there are certain conditions we created to see that how it is affecting the performance. It's like a simultaneous power on of both CPU, how it is behaving, whether they are coming on as independent or as a primary or standby or as a failure mode. Then there are mistakes in connecting the links we try to simulate. Then mistakes in setting the rack address, trying to give a duplicate addresses, or there are inserting wrong module in a module location which is already configured for some other module. Then placement of new module in spare slot, or response of RIO network in broadcast, response of different network modules in broadcast due to any malfunctioning of switches. Then mismatch of application program between active and standby CPUs. Then any interruption in the Ethernet network during a program download or program changes on the online changes, then while changing the CPU roles, then introducing another device in the network and trying to query the RIO, then effect of mismatch of RTC between active and standby CPU. These are the tests as per the Iec requirements. All the type tests like a climatic, mechanical, EMC, and a verification of the functional requirement, voltage range, ripple frequency range, external power supply variation test, and a verification of input-output requirements, and verification of validation of hardware and software. This EMC test conducted on each module as a system. Then programming software. Whatever the programming software customized for Nikon PLC, we have done an extensive review. First of all, the user interface and features, then downloading or uploading, function blocks, then error handling, then support for different programming languages, user-defined DFB blocks programming, then online monitoring program, forcing of bits, then simulation of logic without a physical CPU, connectivity of SCADA with a PLC simulator for SCADA testing, list of bits or register which are forced, print of logic variables for documentation, Excel export import functions of variables, export imports of logics. And further, what are the functions like search and replace, different data types supported, memory map assignments, then support for maximum timers, support for maximum P and ID, retrieval of timestamp dynamic and in addition to that, a complete Modbus mapping done into the EC SCADA software and tested. Then burning test planned for 100 hours, that is with at ambient temperature and with all panel doors closed. All the parameters and diagnostics were continuously monitored for all the links, time modes and temperature. It was 24 hours on. And in between performance parameters also verified. And fault tolerance also checked during this testing. Then primary and standby CPUs were changed the roles and tested the abort test again. Here, as per the checklist already I explained, the major activities I am trying to explain is a repetition only again, but I want to just explain what are the see, we have tested the architecture with master and hot standby CPU, whether it is meeting our planned requirements. And mainly we try to load the program into 32 node and networks. Wherever inter-PLC connection is required, 9 nodes also connected. And identified by all the PLC modules and supporting devices to be tested. Reviewed the test cases prepared by designers to test each and every PLC module. And these test cases were verified and changed wherever it is necessary to have different functions to be tested. And wherever errors were developed, it was corrected by the designers either immediately or a later time, and tests were repeated multiple times. And specification of digital output board was modified to meet the pulse output requirement, as I explained earlier. This also was reviewed and tested. And the PLC communication involving this inter-PLC nodes, that was tested with 8 inter-PLC nodes having physical PLCs. Then reviewed the test cases for EC SCADA communications. The number of screens developed as either process flow sheets or as a listing, and connectivity with the PLC was established for 100% IOs. And reviewed the test cases for various switchover conditions between the master or hot standby PLC CPUs, and the switchover time was measured. Reviewed the test case of verification of various system diagnostics, and performance specifications were reviewed as per the test cases mentioned, and reviewed the application program developed for abort testing. Wherever it was required, it was modified and tested again. And power supply interruption and variation tests were conducted. Hardware qualification test procedures and reports were verified and cleared. And based on review comments of above mentioned, additional test cases were finalized and included in SIDP. As part of evaluation process, all the built-in fail-safe design features were tested with different failure modes injected. All the new or revised hardware designs were also tested by physically injecting faults and verifying the response. Tests were included for the functional and the performance testing of the power supply boards to take care of whether it can work without any deterioration in the performance with entirely 17 slot filled up. Like we filled up, because 17 slot backplane when we use, we can have a 14 number of IO modules. The maximum time the power consuming is basically AA module. We try to fill entire 14 slots with AA modules and measure the current consumption and run for a number of days. Then performance evaluation carried out for analog current input module using hard transmitters also, because we'll be using hard transmitters or hard communicators also in the analog input line. So whether any effect is there, we tested. And the setup was subjected to 100 for burning test. And the Nikon platform designers, they had released a CPU board based on a latest high performance processor. And this was required because the existing, whatever the processor used in the existing board may get obsolete within short time. And there was some performance, faster cycle time requirement was there, like I think ISRO people were explaining. So a new board was developed, and this board was tested in the test facility by replacing the existing CPU board. And all the test, whatever we mentioned, it was repeated, like a communication test, changeover test, everything. And we generated a test report called a System Integrated Test Plan, which can be shared with who are the users who wants to review the test reports or the performance. And to conclude, adequacy of Nikon PLC for C&I requirement, we had ECL had developed a large process. See, basically what happened, we had implemented a data acquisition system for different NRV block plants at Tarapura, Kalpakam. Most of the job was done by ECL only. So recently, ECL had done a similar job at Kalpakam for a reprocessing plant. So to simulate the similar functions, the same logic and the screens of the that reprocessing plant was implemented in the Nikon PLC and EC SCADA and tested for all the functional requirement. And this was tested with existing CPU board as well as the new CPU board. And with the older CPU board, actually the cycle time was set at 200 to 250 milliseconds, and we could get a scan time of around 100 to 120. Whereas with the new CPU board, it was reduced to 50 to 60, almost like a 50% reduction in the cycle time we could achieve. And NRB has a certain requirement, even though actually the cycle time is around 120 to 150, we have some requirement of a faster cycle time, not for 100% IOs, few IOs. So this also was communicated to Nikon designers, and some method was devised to acquire the data from the RIO itself directly, where we could get around 10 to 20 millisecond scan time. And this also was tested, this POC was conducted, and this will be implemented for NRV. And at the same time, there was a committee of experts constituted by Directory Engineer Group ERC for independent verification of validation of hardware and software. And NRV projects INC requirement, basically, we need a safety class IC. And the first, the initial verification validation is being done as per the IC requirement. And later, I think it is expected to complete it in 6 months. And later, the validation for IP and IA will be taken up. Based on all the interactions or the testing by the evaluation committee during last 2 to 3 years, the evaluation committee had concluded that Nikon PLC has been developed following a systematic engineering process with robust inbuilt features of fail-safe design, diagnostics, and fault tolerance. And in addition to that, actually, it's a 100% indigenous design. And the evaluation committee decided to accept this Nikon platform for the C&I requirements of NRV projects, and given the clearance for the production of 10 number of PLCs with a total IO of around 30,000 quantity. And the committee would like to give an acknowledgement to Sri Vaidya Saab. He was the driving force behind the design. And we are very much thankful to ED Nuclear, heads CR&D, and all the designers from our CND, ECL, and Iec group for being part of the testing and evaluation. This is just a list of the team who are involved. And I think many of the people who are in the evaluation committee, they are present here today. Maybe few people could not make it, like Daniel Babu or Niket Munch. They were all very much involved in the testing. They could not make it today. Thanks. Before just completing, I would like to say a few words. Like this is a large-scale platform already developed and which is required. But NRB or like other organizations, they may need a PLC of a, I can say micro or mini, maybe with up to maximum 5,000 IOs requirement, with a small form factor. And ECL had promised actually they will be developing and they will provide it. But this need to be developed and tested in a short time, because NRB, because currently already the plan concession is getting over. Main PLC we are given the order. There is a requirement currently itself for the small PLC also. We expect ECL to complete the design and the testing of the smaller PLC also at the earliest, so that we can use indigenously developed PLC for that application also, instead of going for a MNC product. If it is not coming in time actually to meet the project schedule, we may have to go for a MNC product also, which you would not like to do that. That's one point. Second is, this is a very large audience already available. I think there are so many people from different organizations. So they all have a need, but basically I will be talking about our requirement. Like NRB knows whatever the product available, and we have done the evaluation. But there are many groups or divisions in BRC itself who has such a requirement of PLCs of small or large scale, and people are not aware of what is being done by ECIL or what is the development going on. So many queries used to come to me about some product or the tenders when it comes. I used to explain what are the details I could make. So what I am suggesting to ECL is they should arrange a presentation at Trombe, Tarapur or Kalpakam, that I am talking about only BRC or the DA requirements, to make our departmental people first aware that actually what is a platform already designed and made possible, which can be used for their projects. This is very much required. And a similar events can be organized. I'm not telling it this scale, I'm telling a presentation only, to other organizations like ISRO or defense or even private sector at different locations. That will help in, one is actually utilization of the indigenous technology in our department. Second is for marketing the ECL product. Thank you. I think any queries will be answered, I think, later during the designers' papers.
Thank you very much, sir. Now I would request our worthy chief guest, Srimati Anita Behre Madam, to honor Shri K.P. Rajiv sir, GM Nuclear Recycle Board, by presenting a memento as a souvenir of his contribution to the Nikon PLC and SCADA project.
Why these notes are coming? How to get rid of these notes. Really? So there it's okay. So good afternoon, ladies and gentlemen. Today I'll be presenting IB&V, the process we have gone through for the independent verification and validation of the hardware and software of the Nikon PLC. Now, before I go into what we have done, just briefly for the sake of the audience who are not from the nuclear domain, I'll just briefly touch upon the standards which we have followed for our verification and validation. So as you know, we have for our nuclear safety codes and guides which we have used is AERB. So AERB codes and guides which we have used are as follows. So we have SGD1 which gives basically the safety classification. So in our nuclear domain we have a safety classification of IA, IB, IC and NINS. So I'll briefly describe that later. Then we have D10 which gives safety systems of PHWR and D20 which tells about the safety related. So basically in these guides the safety systems are divided into two, safety critical and safety related systems. So these are the two guides. And then we have the D25 which gives the computer based systems for PHWR. So basically it is giving what are the design, how to go about with the design and how to verify and all those things are detailed. So these are largely based on these IEC standards and they are customized for the nuclear domain. Now if you see safety classes as per D1, you have for civil and mechanical, you have 1 to 4 and NINS class. Then for electrical, you have EA, EB and NINS. With this, no and INC, we have IA, IB, IC and NINS, which is not related to nuclear safety. So now I come to the INC design requirements for class IA system, which we call as the safety critical. So here, you know, the basic premise for design is it should be very simple, it should be verifiable, and it should not implement any function which is of the lower class, that is an IB function or an IC function. Then you must have redundancy to so that you have single failure criteria. Then you must have independence and isolation. This independence and isolation should be between the safety and non-safety, between safety classes, between redundant channels. Then you have to cater to CCF, whereby you have to give diversity so that there is no common failure which affects the system. Then it should be qualified, and then there should be testability built into it, and it should follow the design guidelines laid out in SGD10. Now the safety related, which we call as IB, so here also the redundancy is desirable. Here you have to comply to the guide SGD20 and it has to be qualified. And then we come to IC. So here redundancy may not be necessary, can be COTS and compliant to D20. Now just to, because outside the nuclear domain people are more familiar with SIL gradings of so here just giving a brief comparison based on the reliability figures. So what we find is our classification of IA basically corresponds to SIL 3. So if you see the figures of probability, reliability figures, we find that IA corresponds to SIL 3. Whereas for IB and IC, the AERB guides are not specifying quantitative figures for reliability, but based on the correspondence, we find that SIL 2 is IB and SIL 1 is IC. And now I come to D25, which is basically related to computer-based systems of PHWR. So here it covers all IA, IB and IC classes. Then it covers hardware and software. Then it focuses on the safety case. That is, you have to prove integrity and safety of the software. So here you have to show the correctness completeness with respect to the requirements. Then they are based on reviewable engineering process used during software development, and then documentation, which is the cornerstone. It should be fully documented. Then it addresses both bespoke as well as pre-developed software. So it is addressing both, in both the cases, what is the methodology to be followed. Then it addresses software as well as firmware. So as you know, these days the designs, we have lot of FPGAs, CPLDs, and these also have programmable content. So they also have, it is addressing the methodology for verification of these designs as well. Then it addresses general purpose language like C, C++ versus application-oriented language. That is, you know, function block diagram, ladder diagram, such things. Then it also addresses tool qualifications. You know, you are using a compiler, you are using a static analyzer. So all these also have to be, their qualification or certification is also addressed here. Then it addresses generic certification of like tools, platforms, PLC. So this is where, you know, our PLC, it's a platform which will be used to configure various systems. So we have to qualify this platform so that you can build reliable and safe systems using this. Now I come to the Nikon PLC product line. So this platform consists of safety, means it has variants for class IA, IB, IC and NINS versions with a unified set of electronics hardware. So the hardware is kept common, and it's only in the software that by tailoring, using subsets, that you will be configuring IA, IB and IC. Since the hardware is common for the entire platform, it has been subjected to the development and review process which commensurate to a safety class IS system. Now, in case of software, the development and review process appropriate for the safety class has been followed. And a committee has been constituted to conduct the IV&V of the Nikon PLC hardware and software. So we have a task team which looks after the hardware, and the other one which is taking care of software. So currently we are only doing the software V&V for safety class IC and NINS. So IA and IB will be subsequently taken up. Now if you see the development cycle, I don't think it's readable, but I'll just read it out to you. So in this development cycle, basically it starts from the requirement stage. So once you have the system requirements, then from there you evolve an architecture design. From the architectural design, you have the hardware requirements and software requirements. Now, once the hardware requirements are frozen and software requirements are frozen, you go to the hardware design stage. And similarly, on the software side, you will do the software detailed design, which will be followed by implementation. Then in case of software, you will go through a unit testing of the software before you integrate it and test it with the hardware. And once the full platform is tested, then you will have the complete system validation. So in following this whole process, the verification process is flowing parallel to it. That is, as and when each stage comes, you have to verify at that optimal stage. So in hardware design, see what are the things that we are addressing. You see, we follow a life cycle approach which spans from requirement specification to the O&M. Then you have reviews, verification, then auditable records, then you have extensive documentation, and then quality assurance plan. So the requirement phase, you will have the quantification of performance like capacity, speed, accuracy. Then in reliability, you will have MTTF and MTTR specified. Then physical, what are the dimensional requirements, like somebody said they want a mini PLC, a micro PLC, like that. Then environmental, in what environment it will be operating and has it been qualified for that. Now when we come to the design, you have many features which you will be seeing, like fail safety of the system. Then what are the failure modes? It should not, when you deploy in safety systems, they should not fail in an unsafe mode. Then you have, you do fault tree analysis, then you do FMEA, failure mode and effect analysis. These are all extensively performed. Then online testability, then test coverage, whether how much of the hardware your diagnostics is able to cover. You have to give the coverage. Then maintainability. Then in diagnostics, like, features like whether a hot swappability is required. Then you do sufficient derating of the hardware. Then tolerance analysis and environmental qualification. So these are the aspects which are addressed in the hardware design. Then comes VNV. Now at the system level, you have a system requirement specification. So here you would say it is the platform requirement specifications. And then you have an architectural design document, and then you will have the integrated test procedure and report for the complete system. In hardware documentation, so now I'm basically coming to what is being done for this Nikon PLC platform. So here, extensively documents have been prepared. So we start with, hardware quality assurance plan, which details what is the quality program, assurance program that is going to be followed. And then we have the hardware verification and validation plan. Here also we detail what is kind of verification validation will be done, what will be the reports which will come at various stages, which need to be auditable. Then at module level, each module we have a hardware requirement specification and then hardware detailed design, which will culminate in the schematic and other things. Now, if the hardware has some FPGA based design, so then there we have again a FPGA requirement specification and its detailed design. And then again the test procedure and report for FPGA, then module level test procedure and report, hardware reliability analysis. So this is done, the reliability figure is calculated for each board after its design. And then you have the user manual. So these are the documents that we that have been made for our Nikon PLC, and they are undergoing verification and validation and almost nearing completion. And almost like 140 documents have been made for this platform. Then we come to the software documents. So here again you have the planned documents of SQAP and SVVP. Again for the what is the quality assurance plan, then what is the V&V plan. Then a very important document is the software configuration management plan. Where how any change is documented, implemented, verified, how the versions are maintained. Then you come to the software requirement specification and then software detailed design. Then you also give the programming guidelines have been made for this platform, and they Mishra C guidelines have to be followed. What are the constructs of the language which should not use? So all that is specified in this guidelines. Procedure and report. So once the software is made, each module of the software is tested thoroughly for all combinations of input. So this is the software development process. So it flows like this. You have the software requirement analysis. Then you have the parallelly, if you see, the independent V&V flows to this. And then these from the requirements, you have the design. Then again, design verification and quality assurance plan. Then coding and unit testing, integration, and then the system. So this is the complete development process pictorially shown. And you have these plan documents which are made, SCMP, SQAP, SVVP, these are all. So this has been, this process is being now followed. So if you see here, after each phase, you have a review report for that phase, and where you trace to the previous phase that, for example, from requirements, all the requirements have. So in order to give us a small list of checklists, so they have to see that all these things are met, and only then you say that it has been complete. So for example, have the requirements been classified based on priority? Then what are the deadlines for important functions and data accuracies, timer, node and data integrity requirements, traceability with SYRS and SAD, and then reliability. Then we come to the SDD checklist. Established design guidelines are followed. You have to ensure. Then self-supervision, software like watchdogs and software flow check, data integrity check, module entry-exit checks, then ranges and illegal combinations of input, recovery from computational errors, then data initialization before processing, fault detection and handling, deadlock and timeout checks, presence of missing or unserviced interrupts. So basically, this is the methodology which is being followed for the IVNV of this Nikon PLC hardware and software platform. And we will be shortly completing the IVNV for this IC and NINS platform. Then we come to the code analysis and review. So you do a code walkthrough. So ensuring a safe subset of C is followed. Then checking important violations like undefined referenced, equality comparison of floating point, then code maintainability. So basically you have some metrics, which tell you how complex the software is. So like essential cyclomatic complexity, which is maximum 6, then essential knots, maximum 7. Then we also look for presence of unused functions, presence of deadlock conditions, and then checking state transitions in state machines. So these are some of the important checklist items which are followed during the code analysis. Then comes the software QA audit. So basically what happens, the IVNV team is doing its job of verification, producing review reports. Then subsequently there will be an audit to see if all the things have been done properly. So here is software QA audit. Assurance is obtained that software development and integral process comply with the approved plans and standards. So we had made some SVVP, SQAP, so all those plans, have they been followed or not? Assurance is obtained that the transition criteria for software lifecycle processes are satisfied. Then software conformity review is conducted. Then organizational responsibilities and interfaces are defined. Organization level quality standards, have they been followed? Those things are checked. Project program management process is in place, it ensures. Then all planned documents are available, they are reviewed, and they have been approved. So these are all the checks which are done during the software QA audit. Then software requirement design has been reviewed, software is verified and validated, and the configuration and change control is in place. So as we know, this is a very important step because any change, and changes do happen in software and they have to be very carefully handled. And then you have formal reviews and audits being conducted and minutes approved for transitional phases. That is when you go from, say, design to implementation, those kind of transitional. Process for problem identification, reporting, correction, and tracking is in place. So then you must have a proper process for if there is a problem identified, then how do you report it, and how do you correct and track it. Thank you.
Thank you very much, Madam. Now I would request Srimati Anita Behre Madam, Director ENI BARC, to honor Srimati Anuradha Maya Madam, Head CNID BARC, with a memento for her significant contribution and valuable time in
Prasad sir, ex-head of CNID. I would like to request Shri K.S. Prakash Rao sir, ex-AGM from CAD, to come on to the dais. I request Shri N. Nageshwar Rao sir, ex-head from CAD, to come on to the dais. I would request Shri T. Narsingh Rao sir, ex-senior DGM, to come on to the dais. I would request Shri G.V. Rao sir, ex-head of CAD, to occupy the dais. I would like to request Srimati P. Sailaja Madam, ex-senior DGM, to come on to the dais. I would request Shri Vishwakumar sir, ex-senior DGM, to come on to the dais. I would request Shri Giri sir, ex-senior DGM from RPD, to come on to the dais. I request Shri Sharat Chandra sir, ex-senior manager from CRND, to come on to the dais. I request Shri S.V. Srinivas sir, ex-senior DGM, to come on to the dais. I request Shri Noor Ahmad sir, ex-head from CRND, to come on to the dais. I would request Shri P. Ramakrishna sir, ex-head of RPD, to come on to the dais. I would request Srimati Sarojani Madam, ex-DGM of CRND, to come on to the dais.
Please give them a huge round of applause. Sir, can we have the group photo now, please? Thank you very much, sirs and madams.
Without any delay, I would now request Srimati Himabindu Madam, Senior DGM CRND ECIL, to deliver a presentation on Nikon PLC architecture and product lines.
Respected CMD sir, ex-CMWs, all other dignitaries, and ladies and gentlemen. I am Himabindu from Corporate R&D, ECIL. So today my topic is, I will be presenting a small lecture on Nikon PLC architecture. The agenda of this program is, I'll give an overview of the architecture along with Nikon PLC components, variants, and different configurations. And what are the product lines you have to order for this PLC. And the Nikon
extend better.
Then you get it. So this is the agenda of the program. I will be covering Nikon PLC architecture, which comprises of various components, different PLC variants, and configurations it supports, and the different product lines. So the architecture of Nikon PLC is based on unified electronic hardware, which is designed to qualify SIL3 requirements. So this electronic hardware is scalable based on the I/O requirements of any configuration. Remote I/O nodes are configurable and scalable, and the electronic hardware supports robust diagnostics. It covers wide diagnostics with quick error detection, and we provide safety integrated circuits which provide safety outputs in case of failure, and that is supported with local watchdog timer in each module. And security by design is provided by system security module, which provides two-factor authentication for any complex to configure any parameters in the site. And coming to the Nikon PLC components, the major components in any PLC are control rack and I/O rack. The control rack consists of different modules on the same backplane, namely the CPU module, and remote I/O master, SCADA interface module, PLC communication module, system security module, and power supplies. So we provide dual power supplies to facilitate redundancy. The CPU module interfaces to all these modules through a single backplane. And coming to the I/O rack, we have a remote I/O slave module, which acquires data from all the these analog and digital I/O modules which reside on the same backplane. The different I/O modules supported by these Nikon PLC are digital I/O modules, analog I/O modules, RTD inputs, thermocouple inputs, pulse I/O modules, and relay output modules. And coming to the Nikon PLC variants, we have two variants, that is Nikon S and Nikon C. Nikon S is for secured NPP and strategic applications, and Nikon C is for industrial and commercial applications. And both the Nikon S and Nikon C are based on a unified hardware platform. Then coming to the PLC architectures, we support standalone configuration, dual redundant hot standby configuration, triple redundant configuration, triple modular, as well as distributed configuration. So in this distributed configuration, different PLCs communicate with each other through inter-PLC module. And coming to the Nikon PLC product lines, in Nikon C, we call it as Nikon 1000 series, and under this 1000 series, we have standalone architecture as well as redundant architecture. That is Nikon 1100 series and Nikon 1200. And coming to Nikon S, we name it as Nikon 2000 series, and in this we have standalone architectures which is called, which meets the safety class Iec requirements, and 2200 series which meets safety class IB requirements, which is having redundant architecture. And next one is Nikon 2300, which meets safety class IC requirements with redundant architecture. So what we mean by safety class IA, IB, IC, that I will give in my next presentation. Here we are comparing the probability of failures of nuclear and process industry. When we compare the probability of failures, you can see here, SIL level, SIL 3 is equivalent to class IA, SIL 2 is equivalent to class IB, and SIL 1 is equal to class IC. Only thing is, when we see the high demand or continuous mode of operation, in that mode, probability of dangerous failure is calculated based on hourly basis. And for low demand mode of operation, probability of failure is calculated based on demand, means probability of failure on demand. So indirectly what we say is, if our system meets the requirements of class IA, then automatically we are meeting the requirements of SIL 3. Only thing is we have to get the certificate. Then coming to the programming softwares, programming softwares, we have two series for Nikon C and Nikon S. Programming software for Nikon C is EC Logic 10, which is IEEE 6.1 compliant GUI-based programming software, and it supports all the 5 programming languages, namely ladder diagram, functional block diagram, structured test, instruction list, and sequential function chart. And the software of this EC Logic 10 is based on Linux-based courses software, programming engine, and we have already developed in-house associated tasks which are related with courses. And for Nikon S 2000 series, that is supported by EC Logic 20. This is an indigenously developed IEEE 61131 compliant programming software, and it supports 2 languages, namely functional block diagram and ladder diagram. And for Nikon S series, we have developed an indigenous ESOS RTOS, which resides on the CPU and all other modules. And indigenously runtime software also is also developed for this Nikon S series. And coming to the specifications of Nikon 1000 series, we have 2 variants, Nikon 1100 and Nikon 1200. In both the configurations, the number of channels for different modules are same. The only difference is for Nikon 1100 series, it is a standalone model where you do not have any CPU redundancy. The CPU and I/O. So the maximum number of I/O supported is limited. That is, maximum is only 448. But when you go for Nikon 1200 series, we are giving CPU redundancy along with remote I/O nodes, and maximum of 32 remote I/O nodes are supported by this Nikon PLC. And coming to Nikon 2000 series, CPU redundancy for Nikon 2100, we have 1 out of 2 logic or 2 out of 3 voting logic circuits are provided. And for 2200 series, it is a remote I/O configuration, remote I/O interface over robust proprietary protocol. So this is just a configuration of Nikon 1100 series standalone model, where we have CPU, SCADA interface module, SSB module, and I/O modules on the same backplane. Standalone configuration with single backplane. And suppose if you want standalone configuration with more number of I/Os, we have extension modules which can cater to, that is, we can have maximum 2 extension modules connected to a standalone PLC model. So with a single extension module, we can accommodate 24 I/O modules, and with 2 extension modules, we accommodate 36 I/O modules, supporting maximum of 1152 I/O points. And coming to the redundant solution, we acquire redundancy through I/O's redundancy, network redundancy, or by CPU redundancy. So network redundancy, we provide, we support for star topology or ring topology. And for I/O's redundancy, 2 remote I/O nodes can be configured as redundant nodes which support each other in case of failure. And this automatic data transmission, it is provided in terms of redundancy when we use 2 CPUs to provide redundancy. And higher availability is achieved when you provide redundancy. Then in terms of when the system is providing redundancy, we see for switchover time when there is a failure. So in case of any failure, so the switchover time from active to standby is within 2 cycles. So when the switchover time is within 2 cycles and we are providing bumpless changeover, that is, whenever there is a changeover from hot to standby changeover, there will not be any impact on the process. So this is the screenshot of switchover time with 2 cycles, which we have given to IPRC ISRO. The cycle time was 10 milliseconds. As you can see in these pictures, the difference delta T is 18.27 milliseconds and 17.92 milliseconds. So here there is a square waveform, rectangle waveform, where we are updating the digital outputs, and other waveforms are analog outputs. So at the time of switchover, it could change from active to standby within 2 cycles, that is within 20 milliseconds. And this is the pictorial model of a redundant CPU system using ring architecture network. So with this ring, we have used dual rings and coupled at 2 different places to avoid multiple failures within the ring. So here the active and the main CPU and redundant CPU, they acquire data from the remote I/O nodes through ring topology. And this is just a pictorial diagram of active and standby PLC. The active PLC acquires the data from the I/O node through this remote I/O master. The slave module acquires the data of all the I/O modules in 10 milliseconds and updates the data to the I/O master. And here, this active and standby PLC are connected through an Ethernet link for synchronization of the data, that is Ethernet link. So by using Ethernet link, we can go directly up to 100 meters, and if the distance is more than 100 meters, we connect through fiber converters, fiber optic link, and we can extend up to 3 kilometers. And the main components of Nikon PLC redundant systems are CPU and RIO master, SSB module, SCADA network, and external PLC network module, all residing on the backplane, same backplane. So the CPU sends and reads and writes the data to all these modules through dual port memory provided in each module. The remote I/O master acquires the data from all the remote I/O nodes through Ethernet protocol, and we can connect maximum up to 32 remote I/O nodes. And the external network module interfaces with the different DCS systems, and maximum we can connect, read data from 16 PLCs. And This is a dual redundant configuration where we have two standby PLC nodes and two standby PLC systems connected to a switchover logic. So in this configuration, each system acquires the field input data, performs the processing and updates the outputs. Only the active system outputs will be updated in the field. So whenever there is a failure in one system, the second system will take over and update the outputs. And this is the TMR configuration where 3 standalone systems are connected to the field through 2 out of 3 voting logic. So all the 3 systems acquire the data from the field, perform the processing and update the outputs. Through this voting logic, field outputs will be updated. In case of failure of one standalone system, second system takes over, remaining 2 systems take over, and when the second system also fails, then the outputs are updated with safe-stepped outputs. So we have set up a Nikon PLC test facility at ECIL with 32 remote I/O nodes and another system with 9 remote I/O nodes. So the major components of this test facility are we have used all secured networking components, communication protocols, in-house developed HMI, SCADA servers and workstations, and we have provided dynamic I/O simulators for all the I/O modules to actively simulate the I/Os for all digital and analog I/Os. This is the picture of the 32 node setup, which you will be visiting tomorrow in our ECL. This is just the pictorial model of redundant system where we have 2 CPU racks completely redundant, and remote I/O nodes, maximum we can connect up to 32 remote I/O nodes. And coming to the modules ordering information, all of you are provided with brochures. So there you can, in this brochure, you have the information for ordering all the modules. Each module is provided with a model number, and depending on the requirement, you can order them. Thank you very much.
Thank you, Madam, for providing us a clear insight into the genesis and evolution of PLC. I now request Srimati Anita Behre Madam to present a memento to Srimati Himabindu Madam.
Now, I would like to request Sri Mohit Kalra Sir, Scientific Officer G from RCND BARC to present the details about the features of PLC modules and qualification testing.
Good afternoon to all of you. Before beginning, I would like to thank Shri Y.S. Maya sir. It was indeed his vision to have a PLC at the DI level. Thank you, sir, for your kind support. We are here with your guidance and support.
स्क्रीन शेयर का मेनू आता है ना वसीम के वसीम बोल
Myself, Mohit Kalra from BARC, and my colleague Gauri Shankar from ECL. We are going to present you the features of the PLC module and their qualification testing. The I/O modules and CPU modules are the basic block of any PLC, and we are going to talk about that. My agenda is to give you the overview of Nikon PLC system. From the module point of view, I'll not take much time there. Then I'll talk about the Nikon PLC modules and their assembly. And then we will have some classification of the Nikon PLC modules, how they are classified. And then we will have a little bit features of the I/O modules. And then if anybody is interested, we can discuss it after that. Features of communication module, features of CPU module. And then finally, we will have a qualification test done on these modules. Nikon PLC modules, basically we have divided into the 4 parts. One is the CPU module. CPU module will have a different type of firmware based on the standalone architecture, master standby architecture. Then we have a communication modules and I/O modules, and one is a power supply module. These all I/O modules are intelligent I/O modules. What do we mean by intelligent? That they don't require any CPU intervention. Means if the input module is there, it will scan the field inputs without any CPU intervention and pass this acquired field data to the CPU on the backplane. They are all compact design, ruggedness. They are hot pluggable in the system. Fail-safe modules. Fail-safe modules, when we talk about, all the output modules can generate the fail-safe output independently without any intervention of the CPU. Best-in-class diagnostic coverage. I'll cover the diagnostic coverage in the detail when we discuss about each module. And our all modules have no jumper. Even the backplane has no jumper. And with the ECL, we are going to provide you a long-term support. I'm just showing you the module and the backplane assembly. Here it is our enclosure. Then the green one is the PCB board. And the yellow one is the back cover. And then we have a display window and the display cover. This is the rack assembly, where the pink one is the base plate, and then we have a green one is the backplane module, and the yellow one is the motherboard mounting base. And our module goes to the backplane. And from the front side, we have a field connector, that is a 40-pin field terminal. So exactly now, after the module enclosure, the module looks like this. We have seen in the prototype there, whatever we have kept it. So some markings are there on the board, like we have a channel status display block. We have a 4-character ASCII display to display the diagnostic and software coverage. We have a module reference marking, and then we have a removable terminal, just I talked about that. So the Nikon PLC modules are divided, I/O modules are divided into the 4 basic parts. One is discrete I/O modules, where we have a digital input module, digital output module, and relay output module. And then we have analog I/O modules, where we have analog input module, analog output module, thermocouple module, RTD input module, and then millivolt module. And in the counter, we have a pulse I/O module and pulse output module. And then we have a system security module. Shri Vaidya sir, in his presentation, given already some detail about the system security module. And in the communication module, we have a remote I/O master, remote I/O slave, SCADA network module, inter-PLC network module, and fast data acquisition module. One good thing is that in all these modules, the hardware is common. Only the firmware changes whether we are using for the remote I/O master or whether we are using for the I/O slave module. So the basic specifications of the module is same. So common design feature, I'm just covering here. I'll not cover when I'll discuss with each module. EST, EFT, and surge protection as per IC 61000-4 for all field input-output. Onboard temperature and power supply monitoring, we are providing all the logic supplies and the field supplies to be monitored on the board. Local display as shown in the 4-character ASCII display for hardware and software diagnostics. Then we have a non-volatile storage for unique board ID. We are providing a one unique board ID that will be based on serial number, the year of production, so that we can track if any problem is there in that type of hardware. Then we have a backplane bus diagnostics. It is common in all the boards. So any problem in the backplane, like any data line stuck to open or stuck to close, we can detect that and we can declare that the system is faulty and we can switch over to the standby if it is available. And then we have a hot swappable. All boards are live insertion and live removable. Now I'll discuss about the features of each module. The first one is digital input module. That part number is ECS1100. It supports 32 channels inputs, and all inputs are the same type of input that are vetted through the plus 24 volt DC power supply. And we can have 4 groups of 8 channels each. It means that we can connect the 4 field power supplies of plus 24 volt, and we can have an isolation between the 8 channels. So we can create 4 groups of isolated 8 channels. And all modules have a field and logic isolation. And we can have a configurable debouncing for each channel. Each channel you can provide the debouncing parameter that is configurable through CPU. And we can provide different combinations for each channel. Then we have LED indications, 32 indications LED for the channel status. And then there is one provision for auto and demand scanning of 32 channels. The auto scanning will be configurable from the CPU, and it will do the scanning of all the field inputs at periodic rate and pass the data to the CPU module. And whenever you select the demand, the CPU will give a command to scan the inputs. Only at that time it will scan the input and pass it to the CPU. And then we have a reverse and over voltage protection for all the inputs. Now I come to the diagnostics part where we have FIT diagnostics. The FIT means finite impulse test. What I'm going to do here, actually I'm going to check the integrity of the input read. If I'm reading input as a 1, I'll try to close the circuit by simulating in the hardware itself that when the field input will become closed, whether I will be able to read it or not. So this is done for each input. I am opening it and I am closing it and checking the logic high or low. Similarly, we have an input wire break detection for all the digital 32 inputs. And ESD-EFT I already covered, but here ESD-EFT and surge protection is also for the 24 volt field input supply. And we have a provision to use last value or configured failsafe value for each channel during module or channel failure. If any failure is there is an option to configure what value to be used in the logic. So this is just a specification sheet. I'll just read it, some important points. Like debounce is here for configurable 1 to 254 cycles of scan time, and auto scan time can be configured from 1 millisecond to 255 milliseconds. Then we have a digital output module. This is ECS1200. It again supports 32 channels, and it gives a source type of output. Again, we have a similar 4 groups of 8 channels each, and upcover isolation between field and logic. Configurable fail-safe output for each channel. We can program one time actually during the power on configuration. We can provide what is the fail-safe value when the board or channel will be fault will be sent to the output. LED indications for the channel status, and onboard watchdog timer to generate fail-safe output in case of any failure. All these boards, output boards, have a local watchdog timer. This local watchdog timer will generate finally the fail-safe output to the field which was configured by the CPU. It is independent of the CPU. Even if the CPU fails, they are going to generate the watchdog. Due to watchdog timer, they are going to generate the fail-safe output to the field. Overload and short circuit protection finally. Again, I'll come to the diagnostic part of digital output module. FIT diagnostics for each channel, similar to the input board. Here we are again providing output load open detection. If the output load is open, we will indicate to the user. Continuous readback of the actual output. Whatever output we are generating to the field, we are reading it back and making sure that the output what we have generated is correct one. ESD-EFT and surge protection for 24 volt field input. And again, provision to generate last value or configure fail-safe value for each channel during module channel failure. This is a digital output module specification. Maximum load current is 140 milliampere per channel. Switching time is around 1 millisecond maximum. And onboard WDT, we can program it from 1 millisecond to 2000 milliseconds. Relay output module. Relay output module supports 8 channels. We provide NO or NC contact output to the field, LED indications for the channel status, and we have a configurable failsafe output for each channel similar to the digital output module. Again, it also has an onboard watchdog timer to generate failsafe output. Here for actually detecting the contact output, what we are generating, we are using the forcibly guided relay with 2 contact outputs, DPDT. They are forcibly guided contacts, so one contact output we are sending for the output and another contact we are using for the readback. So it is giving me the actual, what is the output we have generated on the contact, we are going to read the actual value from the second contact output. This mechanism provides robust diagnostics for the contact output healthiness. Till today actually in TPLC also what we have done actually, we have read of this forcibly guided, we are actually able to read the value. And this is the system security module. Actually, it was discussed by sir in the morning. Vedya sir already told you about this. I'll just touch this. This supports the 8 digital inputs and 4 digital outputs. This is a system security module, so we can connect any system input on this module actually. Like if we have a rack door, we can connect the door so that if the door is open, we can generate the alarm through this digital output module. This has a micro keypad for the parameter change, password change. A lot of options are there. 16-character ASCII display provides a complete menu actually. It provides a complete menu where we can go, we can change the parameter, whether it is a floating parameter, integer parameter, or anything it is there. We can enter the signature of the application code. We can enter the signature of the system software code. And 2-factor authentication for critical parameter access, that is one through the passkey, which is in the downside, and another is through the password. And one important thing is that it has a main watchdog timer. The main watchdog timer for the CPU rack, active PLC rack and the standby PLC rack. This is the actual photograph of that, where we have LED indications on the top, and then the 16-character display, where we have a menu-based GUI. So sir has already told you detail about the secured application downloading, secured modifications of the critical parameters. Enhanced diagnostic display. We are displaying all the diagnostics of the RIO nodes also in the redundant architecture on this module actually. Which remote IO node is working, which remote IO node is down. So all these details are coming here. Authentication of the system software, authentication of the application software. All these signatures will be downloaded through this board only. And if when the signature is downloaded and whatever system software application we have downloaded, those will be compared, and if it is okay, then only it will start running. Otherwise, it will go to the halt state. We have a keypad. We have an independent watchdog timer. We are providing the contact outputs outside also, so that can be used. This is the feature of the system security module, where the watchdog timer is again configurable from 1 millisecond to 2 seconds. And we have SRAM, E2PROM on this board itself. This is the analog input module. We have 4 variants of this, 1300, 01, 02, 03. We have a 32-channel single-ended or 16-channel differential and voltage or current. So based on that, the variants will come. Input range is all configurable, but all the input range is configurable through software only. There is no jumper on this board. Isolation same between field and logic. ADC resolution is 16 bits. And here the LED indications for the channel under range or over range. That will be programmed through CPU on the power up. And this board scans all the channels, whether if we are using 32 channel or 16 channel at 3 milliseconds rate. Already it is periodically scanning all the inputs at the 3 milliseconds and passing it to the CPU through the backplane. We have 4 reference channels for online testability of ADC and multiplexers. And under range and over range detection, we provide the soft calibration feature here, where we store the calibration data of each channel in the non-volatile memory, which is on this board itself. This is the specifications, where we can see that the input range voltage is configurable from plus minus 10 volt, 0 to 10 volt, plus minus 5 volt, and current is configurable from 0 to 20 and 4 to 20 milliampere. And for the current, we have a 250 ohm inside this board itself. No need to put it on the terminal block. and the accuracy is around plus 0.1% of the full scale at 25 degrees C, and fast scanning of 3 milliseconds at the rate of 3 milliseconds. Analog output, we have again two variants, 1400 and 01, based on whether you need a voltage output or the current output. It supports the 8th channel. Again, here we have a configurable signal range, and we have a DSC resolution of 16 bits. Similar to that, we have and LED indications for the channel status, short circuit protection for voltage output. And since it is output board, it has a local watchdog timer to generate the fail-safe output in case of any failure. Continuous readback of the actual output. Continuous readback of the configured. Whatever fail-safe value we have configured, we are also reading it back to know that whether it is correct or not correct. If it is not correct, we are going to declare that the board is faulty. So we are reading the fail-safe output also, we are reading the actual output also. And then we have a load open detection for the current output, short circuit protection for the voltage output, and again the provision to generate last value or fail-safe value. This is the specification of the analog output module. It has an 8-channel output where the voltage is configurable from plus minus 10 volt, 0 to 10 volt, plus minus 5 volt. Current is also configurable from 4 to 20, 0 to 20, and 0 to 24. Again, the full scale at 25 degrees C. And WDT is configurable from 1 millisecond to 2 seconds. Rest of the I/O modules will be covered by my colleague Shri Gauri Shankar from ECL. I'll just touch the some communication module, remote I/O master. As we discussed in the architecture, Hemabindu ma'am has presented that we have a remote I/O architecture where the communication to the remote I/O node is through remote I/O master board. This is the It can communicate with 32 remote I/O nodes over dual port Ethernet. So we have a redundancy there in the Ethernet, and whatever data it acquires from the remote I/O node passes it to the CPU through the backplane only. This protocol, whatever between the remote I/O master and remote I/O node, we have developed, it is a robust proprietary query response based protocol based on UDP/IP. Detection and configuration of the remote I/O nodes. It detects how many remote I/O nodes are connected and how many are configured. It checks that whatever number are configured, whether it is there or not. RIO master of active PLC sends the output to each I/O node. So we have a two RIO master in the active also and standby also, but only from the active PLC we send the output to the remote I/O nodes. RIO master software is based on indigenous ESOS and is used in both Nikon C and Nikon S series. So whether we are going with Nikon C series or Nikon S series, this board is common. And this is based on our indigenous developed RT kernel. Since we have a dual Ethernet port, it is receiving the data from the remote I/O nodes on the dual Ethernet port. We resolve the packet. We have to resolve the packet received on the dual Ethernet port from RIO nodes. And what we have done actually in RIO master of active PLC executes 2 queries to RIO nodes in every cycle of active CPU. What it means actually, the RIO master sends 2 times, actually I just told you that it is a query response based. The query is generating the output to the RIO nodes, sending the output to the RIO nodes. And on that, sending the output to the RIO node responds with the input. So in each cycle of the active CPU, it sends twice. It generates 2 times the output data and receives the 2 times all the input data from the 32 RIO nodes. So we are having 2 times here and on the dual Ethernet. So in fact, in the one cycle, we are having 4 packets. So we more or less guarantee that we will receive all the packets and we will be able to send the output and we will be received to input. So I just told you that this board is common as a CPU module. So whenever the CPU module will be discussed, we will discuss the specification in detail. Remote I/O slave module. It sits in the remote I/O nodes and it does the scanning of the field inputs at the 10 milliseconds, irrespective of the cycle time of the active and standby PLC. It is doing the scanning at the 10 milliseconds, and whenever the query will come from the remote I/O master, it will send the acquired input data to the remote I/O master. It also performs the diagnostics on all the I/O modules at the rate of 200 milliseconds and passes this diagnostic information along with the acquired field input to our I/O master. On receipt of any query from our I/O master of Active PLC, I just told you. Our I/O slave software is again based on ESOS, and it is common for both Nikon C series and Nikon S series. It supports the online removal and insertion of the I/O modules, extensive integrity check to detect data error. We have a lot of integrity check on the memory, on the code, on the data received on the Ethernet. And it generates the fail-safe output in case of communication failure with both our I/O masters. If it is not able to communicate with both I/O masters, it just generates the fail-safe output through the I/O module. This will be discussed in detail. Thank you. And rest of the presentation will be covered by Shri Gauri Shankar. Thank you. Thank you very much.
Thank you, sir, for presenting the features of Nikon PLC modules. I request Srimati Anita Behre, Madam, to present a memento to Shri Mohit Kalra, Sir, Scientific Officer G, RCND, BARC. I request Shri Y.S. Maya, Sir, to present a memento to S.V. Srinivas, Sir, ex-senior DGM, CAD. Sir was not available at the time of felicitating ex-employees. Sir, DGM from CRND ECIL.
CPU modules and power supplies of pulse output and counter modules and thermocouple and RTD modules. Out for evaluating this completed some of the modules. In the similar fashion, similar lines, the development work of hardware components and software components were carried out among ourselves actually. But is due to this opportunity to give it to us and to develop such a product, of such a complex product of at this scale. And it is a continuously challenging from our imported vendors. Okay, so it is a continuously evaluating product and we have to keep up the product on par with the market trends. So we thank you very much for both BRC, Iec and ECIL to bring out synergy in developing these Nikon PLC. And now I am going to tell some of the I/O modules and CPU module and qualification test. So coming to this thermocouple module, it supports 14 channels, and so for cold junction compensation, for accurate we need 2 external RTD inputs. And these thermocouples, we support all type of thermocouples. It's configurable from the programming software. And as usual, all our I/O modules isolation is provided, and channel-wise LED status indication also provided. And we have 2 reference channels available for online testability. And so fail-safe also, even though it is an input module, user has the freedom to configure the fail-safe values, depends on the channel fault or module fault. The channel values are configurable very much. And these are the specifications. And this thermocouple module, ADC resolution is 24 bits, and it supports J, K, E, N, all types of thermocouples. And accuracy is around 1%. Completely evaluated by our NRB team. 4-wire configuration, and RTD type also configurable by the user. Any type of RTD it can be connected. Similar lines, it also works on Sigma Delta ADC, which is 24-bit resolution. All these are common features like and input sensor open, close, open and short detection is available. We have extensive diagnostics provided in each I/O module. And it supports PT10, PT50, PT100, PT200, PT500, PT1000. Accuracy of 1%. And it takes 700 milliseconds to scan all 8 channels. So we have pulse I/O module where we are covering 4 pulse inputs and 4 pulse outputs. It's a counter module. It supports both 5 volts and 24 volt signals. And it is various configurations are possible for counter and frequency modes. Pulse and the counter resolution is 32-bit. And it provides for pulse output readback facility is provided. And the frequency also, it is adjustable up to the 1 kHz in this module for pulse output generation. And pulse input, we have 1 Hz to 15 kHz detectable pulse input. It accepts from both 5 volts as well as 24 volts. And the duty cycle, one of the important factors for the pulse output generation, we have 10 to 90% variation duty cycle is there. It is provided for any machine control applications. And we have this pulse output module, we have just reconfigured this module from digital output module. So because the output switchover should be independent of the system scan time, where system scan time, PLC system scan time is highly depends on the process logics and all. So due to that, sometimes there may be a jitter in the switchover. So to avoid, particularly to suit some of the NRB requirements, our digital output module is reconfigured for this pulse output, where we can have all the features of digital output are available here. Still, it supports 0.01 Hz to 100 Hz output frequency generation independent of the CPU scan time. That is one of the things. And the duty cycle also in the similar lines adjustable from 10 to 90%. So apart from these I/O modules, we have I'm going to cover this SCADA module as well as CPU module. This SCADA module, so it is the SCADA module for both our 1000 series Nikon PLC as well as 2000 series Nikon PLC. So it provides SCADA connectivity through Modbus TCP interface, and it also supports fault-tolerant network where media redundancy is provided, but it works on the same IP. But in case of any network failure, and it senses, and event logging is possible. And apart from these functions, we have NTP time synchronization is also provided, time synchronization from the third-party HMI software and to the third-party HMI softwares. We are restricting the connectivity through MAC IDs and other methods actually. And also, since this module is connected to third-party systems, where it is vulnerable to other attacks, but the CPU module cannot affect by the functionality of the SCADA module, where the SCADA module updates the data in the CPU shared memory, and the CPU continues to read its data in polling mode actually, instead of interrupt mode. That's why the CPU module functionality is not at all affected by any events or anything related to SCADA. And these are the physical features which I am going to cover in the CPU module, and it works on Linux kernel. And this is a slave module connected on the bus. Our entire Nikon I/O module, backplane or control rack or I/O rack, all are on VME platform, but mechanically modified. Electrically it's a VME. So coming to CPU module, the CPU module, we are using a powerful RISC architecture, a PowerPC series 32-bit processor we are using, and this CPU module is designed such that it works as a bus master in the backplane rack, and it accesses data from the various modules
like SCADA module, remote IO master, and we have a inter-CPU, inter-PLC module and SSB module. So for CPU, it is a data connected across across the backplane, takes the data from the shared memory areas, and it accesses every memory on polling mode actually, and it stores CPU. It stores the application data as well as code data inside its memory. It has got a flash memory, and the CPU supports 6 MB user program, 6 MB. So earlier, in our earlier versions, we used to support 4 MB. Now we have tested up to 6 MB. And again, this 6 MB is good enough to handle any complex process. So, and it supports 2 gigabit Ethernet ports. Okay, one Ethernet port is used for connecting the programming software. Other Ethernet port is used for connecting the hot standby PLC, other redundant CPU. And these active standby subsystems of CPU subsystems can be interconnected through this Ethernet link or over a fiber also. They can be, depends on the fiber connectivity, we can keep them as long as 2 kilometers, or depends on the fiber mode, we can take even longer also. And this same module, we are proposing, see, the firmware is different. So for all our active standby systems as well as standalone systems for 1000 series as well as 2000 series, this CPU module we are offering in the 2500, 2509, 2510. So 2500 is for remote IO configuration, and 2509 and 2510 is for local IO configuration, where our IOs are connected in 2 different fashions, both for 1000 series PLCs as well as 2000 series Nikon S PLCs. And apart from these features, and we have an independent watchdog timer supervisory circuit, so which will monitor the performance functionality of the processor. So in case of any loops or any, the independent watchdog is going to act. And it provides memory protection, and it provides deterministic performance based on the RT Linux firmware we have used inside this CPU for Nikon C series particularly. And these are the physical features of our CPU. It's a PowerPC processor, 32-bit, and the CPU works up to 1.2 gigahertz. And we have a DDR, powerful DDR memory, where power on it takes all data from the to 512 MB data. And we have non-volatile battery-backed memory is there, E2PROM memory is there to store vital product information of the product. And user program protection is available. The operating modes are active, standby, solo, and run mode. And we have a RTC available in this. The IO capacity this CPU can handle is maximum of 14K analog, digital, or mixed. And the CPU, so it takes only 6 watt power. Even though it works at 1 gigahertz, it takes only very less power. Now coming to this power supply module, we have a formerly this catalog product 230 volts AC power supply module. Entire our modules works on 5 volts DC supply. For field interfaces, we need anyway 24 volt supplies external to the system. But our power supply modules, we take 230 volts from 2 different supplies. And if you see our rack, on both sides we have a power supplies. They work on current sharing mode, redundant supplies. If user wants a redundancy, dual power supply, one more power supply can be taken in current sharing mode actually. And it has got over temperature protection, over current, overload protection, as well as short circuit protection. And there is a on-off switch available on the front also, and it also indicates the voltage as well as the current. So how much current it is drawing each module, each rack. So easily user can identify if anything wrong. And we have extensive indications, particularly for the power supply module. And the health bits from each power supply is scanned through a backplane, and their status is available on the front panel as well as in the SCADA HMI also. the power supply status is available. And it supports over voltage protection, under voltage protection both actually. And the one more important parameter is it supports 50 milliseconds hold up time. Okay, it supports 50 millisecond hold up time, and it supports wide input voltage range actually 180 to 265, and this power supply module is separately qualified for various tests. And hold up time also in the 32 node lab, NRB has evaluated this power supply module very as per the separate test cases are carried out during this evaluation process. And coming to qualification test, I just brief you on the qualification test criteria. So we have, as per the PLC standard IEC 61131, we need to carry out these 10 different EMI/MC tests. And so the entire, if you take our PLC, it's a 32 node PLC, it's a huge system, but the scale down model is chosen. If you can see the model, we have one control rack where all our CPU control rack modules are covered, and IO rack also, all various IO modules are covered in this configuration. It's a scale down model. So we have an excellent facility in ECL, EMI/MC and environmental qualification test facility, all are available. So what is the qualification criteria? We have a system software running from the PC based CodeSys software, where all our inputs and outputs are configured on the screen, configured in the CodeSys, and the third party, the evaluator has to monitor these values while undergoing these qualification tests. If any changes in the display on the CPU or IO modules, okay, so they can see that as a fault and declares according to their criteria. And the qualification criteria for this EMI/EMC is A, B, C, D. A means, okay, the system is not affected. There is no loss of any function. And B means system is slightly affected and recovered on its own. C means temporary loss of the function, but it is recovered on your manual intervention. D means completely hardware or software, it's not recovered after the test. Even after manual intervention also, complete loss of hardware or software. And this is the summary of these tests actually. So conducted emissions, we have two different tests, emission tests, compliance. One is compliance, other one is immunity test. So coming to these conducted emissions, as per CISPR 22, these are the pictures. I just want to give the glimpse idea what is the rigorous process we went through. And before bringing these product, a full-fledged product to the qualification tests, we have our first prototypes itself, we have used the facility to check at a module level, we have tested, and our entire hardware and software tuning, even FPGA codes also modified for the critical signals based on the test results, because our test facility, even though it is NABL accredited, they have two types of services. One is certification services and other one is consultancy services. If it is not certificate, okay, for test and evaluation we can use the facility. Since it is our own facility, we could achieve this compliance, this test in no time, in a very short time actually. So it was not a challenge. We could easily pass the modules at a prototype level, and subsequently after entire software is developed and we have subjected the tests, all these tests after the whole software development. Okay. And these emissions are well within the limits of CISPR 22, and the frequency range varies from 5 to 0.15, 15 kHz to 30 MHz for conducted emissions. And another test is radiated emissions. Radiated emissions means the antenna is placed near the system, the distance between the antenna and system is 10 meters. You can see the it's a radiated RF immunity. Similar way, conducted test, and the profile is as per IEC 61000-11 actually. And we have various profiles like 0% short interruptions. Even this is also qualified as per the standard, suggested by as per the standard IEC standard. And we have a RF, this electrical fast transient immunity test, and burst of noise is injected through the power lines as well as signal lines, and no malfunction is observed, and even this test also criteria A. So two different power levels are applied on both on power supply inputs as well as signal inputs. And similarly, surge immunity also we have cleared in criteria A. And magnetic field also, current magnetic field, you can see the picture of the equipment and magnetic field is criteria A from NPCL, even our peers. And this is the certificate from our lab, ECL EMI-MC test facility. It's NABL accredited facility. And similar way, we have qualified the system for environmental tests also. This is the profile for dry heat, damp heat, each test. So this is for storage, and dry heat for both operational as well as storage. And change of temperature test, it's a thermal shock and thermal cycle test. All these tests we have qualified, the system is qualified, the scaled down model of the system is qualified, and this is a certificate. And these are some of the graphs taken from the chamber. And apart from this, we have one more test called burn-in test, which we subject our systems to 100 or 168 hours. So for the reliability, to establish the reliability of the system. So if you see the reliability, there is a famous bathtub curve. The system failure rate is high during initial stage as well as end of the life of the product actually. To overcome that, to mitigate any process related, manufacturing related defects or quality defects, this burn-in test is to be carried out. And the parameters, monitoring parameters also similar, and we have taken the SCADA screenshot for this. Okay. And this test, we have a scaled down model, completely qualified, is almost 168 hours, means it's more than a week time, completely qualified without any effect of both hardware and software components. Now with this we can say our Nikon PLC system is meets high reliability requirements, high availability requirements, and its maintainability and its safety and security requirements. Thank you very much for giving me this opportunity. Thank you.
Thank you, sir, for presenting the additional and important information on the various modules of Nikon PLC. I now request Shri Debashis Das sir, ex-CMD ECIL, to present a memento to Shri Y. Gauri Shankar sir, DGM CR&D.
I now request Sri R.P. Behra sir from IG Car to elaborate about the roadmap for future development of PLC.
You can see the back actually.
Roadmap.
See the back. Yeah. Okay.
Very good afternoon to all of you. Myself, R.P. Behera, from Indira Gandhi Center for Atomic Research, Kalpakkam. At present, I am heading Real-Time System Division. So my talk is on the roadmap for future development of Nikon PLC. So it's my pleasure that we got one opportunity to develop a lot of modules and could help our knowledge base in developing this Nikon PLC. And the present roadmap is we are planning to develop some new modules for Nikon PLC. Then after that, I will talk about PLC certification process. Then finally, I will tell the obsolescence management, how to manage the obsolete components. At the outset, if you see that all these modules already we have developed, whatever requirement is there for the plants. Now we are planning to develop some new modules. Basically, we are planning to develop some new communication modules based on Modbus TCP/IP master, Profibus DP master, and at the same time, we are planning to develop some of the new I/O modules that is based on the HART communication protocol. Then some special modules like sodium leak detector module, optical encoder module, which is required for fast breeder reactor program. The coming to that HART communication protocol, this is very recent digital technology going on across the world. So we are also planning to develop this set of I/O modules, which will communicate in terms of digital communications, and also at the same time it will get diagnostic information from the sensor. This helps in covering the diagnostic features up to the sensors, and it also allows the bidirectional communications over the 4 to 20 milliamps currents. Implementing HART in Nikon PLC will allow to integrate smart sensor. So nowadays everybody is talking about the smart sensors, and the smart sensor is basically required for this moving forward towards Industry 4.0. So smart is nothing but our self-monitoring and accessing that remote technology. This is the protocol. So this protocol, using this protocol, we can have a lot of diagnostic features at the sensor itself. The sensor itself can tell that whether I am healthy or not healthy, so that the downtime will be less, productivity will be more. So since the time has come, we have to move forward towards the future applications. So the smart related communication protocol is also required to be implemented in Nikon PLC. Then the other module is sodium leak detector module. This is a special purpose module. Actually, large number of sodium leak detectors are required to monitor the sodium leak in fast breeder reactor. Sodium is used as a coolant in the fast breeder reactor. Sodium is highly volatile also. So, and reactive to the atmosphere, so that we have to monitor that leak of the sodium in the fast breeder reactor program. So for that, we are having spark plug type of leak detectors and wear type of leak detector. To address and to interface this type of sensors to the Nikon PLC, we are planning to develop some leak detector electronics. Then the second module is optical encoder module. Basically, this optical encoder module is also required to get the angular position of each rotatable things. So in our fast breeder reactor program also, we are having SRP, LRP. SRP is nothing but small rotatable plug and large rotatable plugs. So their angular position is also required to be monitored very frequently at the time of fuel handling system activities. So to cater to this type of requirements, we are planning to develop this optical encoder module also. And in the future, we are planning to develop motion control modules also. Then coming to the TCP/IP master module, already my earlier speakers, they have already discussed regarding the TCP/IP master modules. So basically TCP/IP is open master slave application protocols. This is vendor neutral also, and the communication is done through digital media actually. So this will help in integrating a lot of field bus instruments. So the advantage is that since everything is going digital, field related noises can be filtered out using the digital technology. So for this, we want Modbus TCP/IP master communication protocols. Okay, then other thing is that the Profibus DP is also required. This is also one type of field bus related activities. Field bus, the beautiful technology is that the field bus, we can communicate the data, field data over the power supply also. That means within 2 hours we can communicate the data to the system, to the master control. So that is the advantage of this field bus technology. And there are so many field bus technologies are available in the market. One is Profibus, the other one, so many are there, like foundation field bus is also there. Nowadays EtherCAT is also coming up. So at present we are targeting for this Profibus sort of master module, so that cabling and wiring can be reduced. This is the biggest challenge and the biggest problem and headache for the plant O&M people, because of large number of cables are routing from sensor to our control nodes. So that can be reduced provided if you are providing field-based technology to the sensors. Okay, these are the future developments. Then finally coming to that PLC certification process. This is the biggest challenges is there. What I personally feel that a lot of insight is required before going for certification process, because the thing is that certification is simply not giving only order to that seal certification certifying agencies like TUP is there, and the other agency is Exida. They are there actually to certify your product. But one thing is that from our side, as a developer, designer and developer side, a lot of inside knowledge is required regarding the product. But basically they will ask what are the type of documents they really required for certifying the products. So at that time, if the knowledge base is there, we can readily support those documents so that easily you can get the certificates. So out of that, if you compare the D25 guidelines and IEC 61508, that is industrial sector, more or less we have done most of the things as per the D25 guidelines. That is our nuclear guidelines. And nowadays, actually, this IEC 6150 says that seal certification, that seal is safety integrity level. Safety integrity level, actually, basically, we have that safety functions are there, lot of safety functions are there in the plants. Each safety function is categorized depending on the consequences. If the consequences is very high, then we have to categorize accordingly. So for that, lot of risk assessment we have to do. That is the first job. The risk assessment can be done provided lot of design details are available to us. So similarly, that if you see that after going for seal certification process, we can easily quantify the number of risks available for each safety functions. So for that, numeric approach is there. So just like that, since seal is there, we should not apply seal 3 you want, because the justification for that should be there. Why seal 3 is required for your specific application? What is the consequences? What are the implications are there if seal 3 is not there? So these are the optimizing the things. We need to have numerical calculations for each and every safety functions in the plant. So because to address the safety and to reduce the number of risk, that we are introducing that this safe and secure PLC in the plants. Then coming to that appropriateness of the protective system, as I already told that so many protective systems are there, but the appropriateness should be there. It should be optimized so that your investment for the PLC or any safety protective system will be optimized. And then the other thing is that third-party qualification is also required. Then market recognition. This is one of the factors where we will get worldwide recognition that yes, our Nikon PLC is also standing on the world platform. Then coming to Nikon PLC development process, already systematically controlled, well documented development process already we have completed, and a platform verification validation is being carried out by independent VNB verification and validation team, where our designers and developers are not involved. Then finally, complete in-house design is associated with us. So because of that, this is the development process we are following for Nikon PLC. Then I will just touch upon what is the requirement of IEC 61508 compliance. So there are three circles are there actually. There are three domains are there. One is systematic capability. The second one is architectural constraints. The third one is the probability of failure. All these three domains are equally important, and the intersection of these three activity will give you the compliance of your product. Basically, actually, one thing I want to clear that seal is not given to the product. Actually, it is certifiable. That means if you are using the seal certifiable product in a safety system, then only it is called your seal 3 qualified. the thing is that it involves both sensors, logic solvers, and finally your actuators. Minus logic sensor and actuators, seal is only the logic solvers. I mean, it is a logic controllers only. The other aspects are there. Where exactly you want to implement, that is also equally important. So the process engineer is also equally important for certifying this type of products. So what I mean to say, worldwide people have already understood that sensor failure is, contribution of sensor failure is up to 35% it comes. Logic solvers, the failure contribution is a maximum 15%. Why it is so? The reason is very simple, because we have implemented automatic diagnostic coverages are there. So automatic diagnostic features are available in the logic solvers. Whereas in case of your sensors, there is no such diagnostic things are available. So for that, the consideration of the amount of contribution for this sensor is 35%, logic solver is 15%, and actuator is up to 50%. Okay, so that is the worldwide concept is there. So coming to our capability requirement, safety integrity level starts from safety seal 1 to seal 4. So seal 1 means where your risk is less, seal 4 is risk is very high. That is the meaning of seal 1 to 4. And all these three capabilities you have to do. Then coming to one more point is, the important point is the probability of failure. Probability of failure is just like that, it's not a number actually. Probability of failure can be calculated by the failure rate of each and every component. Here, we have to consider those 9 factors. What are those 9 factors? Those 9 factors are base failure rate. Then second is your mission time you have to consider. Third one is diagnostic coverage. Then the fourth one is your effectiveness of the diagnostic coverage. Redundancy also you have to consider. What is how many types of redundancy are there in the system? Then some other factors are there. So put together some 9 factors you have to consider. Then the system will be definitely it will pass through the seal certification process. So in this slide, actually, what I am going to say that we have to calculate, as a designer, we have to calculate what is the safe failure fraction. The safe failure fraction, actually, it will tell that how many safe failures are available. So safe failure fractions are not that much important. But if you consider the dangerous failure factor is highly, I mean to say highly reactive and highly risky factor that is available in the system itself. So as a designer, we can tell whether this dangerous failure factor is less or more. That much calculation we have to do actually. Then comparing all these things from some safe failure fraction, if you have hardware failure tolerance is there, hardware fault tolerance, HFT, hardware fault tolerance is there, then we can easily map. For example, that SFF, safe failure fraction, if it is 60%, and if you have hardware fault tolerance is 1, I mean say 1 out of 2 architecture is there, then we can target up to seal 2. So like that, if you have 2 out of 3 architecture, you can target up to seal 3, provided your SFF is less than 60%. If your SFF, means safe failure fraction, is more than 99%, you can easily go to seal 3 and seal 4. So this table gives a lot of confidence that yes, our Nikon PLC can easily pass through this type of requirements. So now I will tell that a comparison between IEC section 508 with AERB D25 guidelines. There are 10 points are there. All these 10 points we are meeting with as per the AERB D25 guidelines: configuration management, life cycle, requirements, validation, design and implementation, selection of pre-developed software, selection of tools, integration, modification, verification. All these 10 parameters are equivalent to our IEC section 508. So the next table actually we have studied thoroughly what are the points are there, what are the sections are there as part of the AERB D25 guidelines with respect to our IEC section 508. So configuration management corresponds to 6.3 to 3.1. So like that, life cycle, requirement, validation. This table is available for our own assessment. So whether we can stand for seal qualification or not. So finally, using this effort, the conclusion is that using the effort put in the SG D25 certification, we have initiated seal certification process for Nikon PLC. This is the comparison table where our IEC, actually our AERB D25 guidelines says IA, IB, IC corresponds to seal 1, 2, 3 like that. Then here one more point is that the probability of failure is also there. That can be converted to how many risk you want to reduce. That is called your risk reduction factor. That risk reduction factor is simply not that inverse you make that PFD, it will come that one. So other parameters are there. Okay, then we'll see that obsolescence management process. Basically, each and every product in the world, definitely one day it will obsolete, and that cycle is very simple: design and development, operation and maintenance. Then finally, it will come to the retirement phase. So we have to track each and every component, whether the component is getting obsolete or not. Why it is required so? Because it affects your plant safety. Not only affect the plant safety, it also involves finance, money also involved. So a lot of effort is also involved to develop the product. Basically, component of obsolescence, why it happens? The functional and the technological market demand. All these three factors: functional, technological, and market demands. Because of all these factors, component failures happens. Because as you know, sir, actually in our semiconductor industry, they are not targeting this process industry. They are simply targeting this mobile industries because their market is very high and the demand is very high. So we have to be extremely careful while selecting the components. And those components we should select where we will get a lot of support, after sales support, and longevity should be very high, and the components should be industrial grade components, failure rate should be very low, proven use should be there. Like that, so many factors, parameters are there for selecting the components for designing all our modules. That also we have taken care during the design phase itself. Then periodic risk assessment also we have to do for the component inventory. We have to see that how many components are getting obsolete over a period of time. Then we have to take a decision what we can do. Whether the component is obsolete, should we go for design refresh immediately or we should wait for some time? That type of decision also we have to take care. Then at present we are having two types of approach, proactive approach and reactive approach. So basically proactive approach is nothing but suppose you feel that one processor we are using the system and it is going to be obsolete after some time, after 5 years or 10 years, then we have to take very proactive approach now itself. Because the time has come that we have to go for a design refresh. Then in case of reactive approach, that is not that much important because it considers all the passive components. Passive components failure rates are very, very less. Even if it fails also doesn't matter. One register can be replaced with another register, one capacitor can be replaced with another capacitors. That is not a big issue. Then finally, retaining the skilled manpowers. So that is what is most important actually, skilled manpower in the sense that persons who has done the design, that we have to retain those resources. Because they are the persons in future, they can design any type of circuits or any type of board when that challenge is required and when the design refresh is required. So we have to retain those manpowers. Retaining manpower is not so easy, sir. Sorry. Then this is the last slide where some of the activities we have done for our one of the systems deployed in the PFBR, prototype fast booter reactor. And we have done this obsolescence management, obsolescence risk assessment we have done. And this design was done by us and it was manufactured by ECL and sent to Bhavini during the year, I think, 2010 or 12. So for last 10 years it is running in the plant. Though plant is not running, but the system is running 24/7. So far we have not received any of the failure from the card. We are very happy that the system is working, performing very nicely. And that system actually we have done the risk assessment, and we found that till today 40% components are obsolete, or some of 20% components are obsolete, another 15% components are going to be obsolete. But still, we are not taking the design refresh activity because the reason is our inventory is very good. Another 20% inventory is still lying with us because there is no field failures or field returns are there. So there is no point in going for a design refresh at this time. So the management can take a decision. So if the failure rate, if the obsolescence rate increases more than 50 or more than 60, then we can go for a design refresh. So that optimization of design refresh is quite important. And we are having this sort of knowledge base, we can take care of future requirements. And sir, you already know that reactor works for 40 to 60 years. So to cater to for long duration of this type of support, to give this type of support for long duration, your system should also work for 40 to 60 years. But it's not possible. Electronic system can work up to 10 to 15 years or maximum 20 years. But since I told that since this particular system is running for the last 10 years and there is no field failure or field return, so it gives a lot of confidence that as a designer, we can do a lot of wonderful things. With this, I'd like to thank everybody, and I'd like to thank ECL for giving a lot of very nice opportunity to me. This is the famous monument the shore temple near to Mahabalipuram and the 8th century temple, still it is standing there. And like that, I hope our Nikon PLC should stand. Thank you.
Thank you, sir, for presenting before us the absolutely lucid pathway for further development of PLC. I now request Shri Debashish Das sir, ex-CMD ECIL, to present a memento to Shri R.P. Behra sir, IGCAR.
Now, I would call upon Srimati Hema Malini Madam, Senior Manager from CR&D ECIL, to deliver a presentation on special features and customization of Nikon PLC.
Today's yes, sir. Thank you. Good afternoon, one and all. Today I'm going to present about the special features, what is the customization we have done for our various customers, for IPRC, for NRB, what we have done, the customization part, and a small overview about the Nikon RTU model. See, we are using, as part of Nikon C for IDE, we are using Courses IDE, which is 61131-3 compliant. It supports 5 languages like LD, FBD, ST, IL, and SFC. And all other features it is supporting, as you might have seen, Courses IDE also is one. So some brief points I want to just outline. That it supports user-defined blocks and user-defined libraries so that we can create our own blocks. We have used this user-defined, we have created for inter-PLC communication, we have created blocks for using this feature in Nikon PLC. And it supports backup and retrieve of user logic. And it supports soft PLC feature also. That means without PLC, without actual hardware, we can configure the PC as a PLC, and we can test your application. You can connect to SCADA, and you can do all other tests and verification. It supports offline simulation, and it supports online monitoring and online changes also. And it supports, of course, OPC UA, OPC protocol, and both UA and TA. So coming to the customization part, first let me explain what we have done to meet IPRC requirement. Here IPRC team is also there. So see, we got this order actually to execute 48 PID loops and all in 10 milliseconds actually. See, our Nikon PLC is designed for 100 millisecond minimum time. So to reduce it to 10 milliseconds, we have done a lot of customization, both in hardware and software as well. See, 10 millisecond means, as per any process standards, 30% ideal time should be there. So the logic has to be executed within 7 milliseconds. Okay, so that the 3 millisecond will be the ideal time. So here, if you say it's 10 millisecond, actual execution time should be 7 milliseconds. So within 7 milliseconds, our application has to be executed, our all data acquisition has to be happen. So all these things. Apart from that, there is a feature they asked, the data logging facility actually.
For all 10 millisecond, for every 10 millisecond, all the digital data has to be logged, and for every 50 millisecond, all unlocked data has to be logged. So for that, we have done, as I said, we have done a lot of customization software as well as in hardware. In software, what we have done, as our earlier speakers told, we have different modules, CPU modules. CPU is there, RF master is there, RF slave is there, which will be running in its own fixed cycle. But to meet this 10 millisecond, the fixed cycle mechanism is not meeting, means it's not adequate. So what we have done, instead of going for a fixed cycle, we made it like, see, RF master will be running in a event-based mode. So whenever suppose if it has to send an output data, it sends the output data, and again it waits for the event to occur. So for every 1 millisecond, it will be running continuously. So whenever it receives the input data from the input, input data from the RF slave node, it receives the input data, sends to the CPU, and again it waits for the data. So like that, with that change of software architecture design, we could able to meet 10 milliseconds. And not only that, when we got the order, we were having a old CPU with 266 megahertz speed. With that processor, we were getting 15 milliseconds actually. See, the IPRC requirement is 6 RF nodes has to be, means within 10 milliseconds, 6 RF nodes. Up to 2K IOs it has to support. So with old processor, we used to get around 15 milliseconds. Then with the new processor, with 1 gigahertz frequency and 1 gigahertz speed, network speed, we could able to achieve this 10 milliseconds, in fact. And one more additional requirement, and one more thing is, though we reached 10 milliseconds, the switchover time we couldn't able to reach within 20 milliseconds actually. Within 2 cycles, we didn't able to get the switchover time. Sometimes we are getting, but sometimes it is going to more than 20 milliseconds. The main reason is, here we are using CodeSys IDE. Okay, in CodeSys, there is a parameter called standby wait time, up to which time the standby PLC will wait for a message from the active. If it has not received a message from the active, then only it switches to They said, no, madam, proprietary protocol. And this communication module supports up to 16 PLC systems. In network, we can connect up to 16 PLC systems. And this network is also redundant network, so that if one link fails, the other one will take over. And one more requirement of NRB is to get the serial data. Actually, in the field, to get the serial data from serial devices, what we have done, we have developed a separate communication module which interacts, which gets the data, serial data via Modbus protocol, and it exchanges to the slave node, RIO slave node, from there to RIO master, and from there to CPU. So this communication module also we have developed. So this is a block diagram. So from the serial devices, through Modbus serial master protocol, the communication module receives the data and exchanges to slave node. And from slave node to RIO master, this will be exchanged via proprietary protocol. And one more requirement of INRB is to get some parameters of input parameters. It has to be read in a fast manner, and it has to be exchanged to a data server or a historian. So for that, we have customized our communication module to this fast data acquisition module, which gets the data from the RIO slave node in its RIO cycle time of 10 milliseconds, and it exchanges to the data server via. This is also a proprietary protocol via proprietary protocol. Okay, like this, all 32 RIO nodes. Means for each RIO slave we can accommodate one more communication module which reads the data, which gets the data from RIO slave node and sends to a historian in a network, separate network actually. And now we got one more order from Iec STC for them. For that, we are developing leak detector. Leak detector module with 8 channels, and there is one more module called millivolt module with 14 channels, which supports 0 to 50 millivolts specification. And here there is here also the communication module is customized, because here some of the leak detected data has to come from the WSN network. So this communication module, it gets the data from the WSN network. It acts as a WSN gateway, and it reads the data via Modbus protocol, and it exchanges to the CPU. So this is also one of the customization. This module we are developing actually. So coming to the enhancements, to meet the oil and gas sector requirements, we customized our Nikon 1100 module. That's a standalone module to support more communication protocol support, to give support. We have developed this Modbus slave, Modbus master protocol over serial as well as TCP. So this model supports all these protocols. Not only that, the most complex protocol like DNP3 and DNP3 SA also we are supporting actually. Recently, we demonstrated this PLC at GAIL, Noida, and they have given clearance also. Means they have added ECL as their vendor list actually now. And so this is the DNP protocol, and another communication with module with Modbus server. We can configure like this. So in GAIL, the system is demonstrated in such a way that the Modbus Modbus node will read the data from serial devices and exchanges CPU. From there to via DNP protocol, it will be transferred to the SCADA. So this we have demonstrated. And this is for miniaturization of Nikon PLC. Actually, this prototype module we have already developed. The production model is going on. This we have displayed in our gallery. Also, you can see the exhibition counters. That's it. These are all the customization special features of PLC, Nikon PLC. Thank you.
Thank you, Madam, for delivering valuable information on special features and customization of Nikon PLC for various platforms depending on the customer requirements. I now request Shri Debashis Das Sir, ex-CMD ECIL, to present a memento to Srimati Hema Malini Madam, SM CRND. Thank you, sir. Anybody has any queries? Yes, madam, please.
Hello. Sir, good evening everybody, sir. I am Kameshwari from Iec. I have few questions, sir. With respect to digital input board, what about the interrupt feature on change of state?
Inputs are not interrupt based, madam. They are scanned continuously, and the data is updated in the digital input specifically. But if any customized requirement is there, we are ready to do it. It's not part of it.
I am Arogyam from IPRC Mahendrali. Actually, when they are discussing about this diagnostic feature, now diagnostic level is available on board level or IO level, and what is the maximum time? What was displayed 200 millisecond, board level. Any IO level is there?
Actually, diagnostics is at the board level, we are passing to the CPU. But all diagnostics are carried out on the channel level itself. Like I told in the FIT case of digital input and digital output, the diagnostics is on the channel, but it is performed at the periodicity of 200 milliseconds, and this diagnostic information is passed to the control rack.
So whether that will have the each channel-wise information? Okay. Okay.
Sir, next question is that for the relay output card, one that is one contact is wired. One contact is wired to the field and one contact is read back. So suppose if that contact gets welded, how will you come to know?
Actually, in the relay output case, it is a forcibly guided contact. So both the contacts are guided to each other. If one is welded, the second contact is not going to change. If it is closed, it is open. If it is open, it is closed. Always this will be the case. During the failure, either both will be closed or both will be open. Because they are guided to each other. If one will not move, another will also not move.
Okay.
So that is a special relay actually, that is called the forcibly guided relay.
Okay.
That we are using in the relay output module.
Okay. So when the process output changes, you will come to know that.
Yes.
Okay. Then you told on every card a watchdog timer is there.
Watchdog timeout is there.
For output modules.
Correct. What is the reference for checking the healthiness of that WDT?
What is the?
Reference timer for checking the healthiness of onboard WDT.
Onboard WDT we have implemented in the FPGA with the timer logic inside the FPGA. So from the FPGA timer logic, we are checking what is the count it has increased. Suppose the timeout we have given 40 milliseconds. So it will not reach to 40 milliseconds. If it reaches to 40 milliseconds, the failsafe output will go to the field. So before that, the retriggering comes from the FPGA itself. Suppose 20 milliseconds always we retrigger. So this 20 counts we will read always, that it is working or not working.
No, but always it should not be at a particular rate, because if it gets stuck at a particular rate, you will never come to know.
No, we will start from the 0 again, because it will start from the 0, the count will go up to 20.
Hmm. Hmm. Yes. Hmm. Okay. Hmm. Hmm. Okay. Hmm. Okay.
Retriggering means reinitializing it to the 0 count.
Okay, okay.
That is the meaning of the retriggering.
Okay. And for IVNV, Anuradha madam was telling about the checklist. Is the checklist really cycle time is linked with the application software? If the cycle time is 1 second or 5 seconds, then the switcher also will take about 2 seconds or 10 seconds, or this 20 milliseconds is the maximum.
No. It depends
No,
on
madam,
the cycle
it depends
time.
on the cycle time, but minimum time requirements are there, madam, where system performance is also considered.
Now, why at all it should be linked with the cycle time of the application software? That
Yes,
is
sir.
my question.
Yes.
Yes. Yes. Hmm. Okay.
Mike.
Yes. Hmm. Okay.
Actually, this cycle time, that switchover, when we are running hot standby mode, prime and redundant mode, okay, we want a very peculiar system for our engine, rocket engine testing or stages testing. You need to decide in the real time, okay, whether this test is performing well, or we have to abort, or we have to stop the test. We have to take very quick, fast response. We have to decide. Otherwise, your process parameter will exceed. That engine may damage, or stage system, whatever test article we are going to commence, that may get damaged. Of course, this sometimes test facility also make it. Where the facility we make for commissioning a facility, we take very quite long time to create one facility. This kind of cryogenic testing also. So we need a process to abort within a quick time. Take a decision whether this main has to be switched over to that.
Yes,
That
yes.
we are only predicting. It may not be okay 10 milliseconds also. We are telling this pumpless transfer. Actually, we call it as a pumpless transfer. When the main fails, we have to transfer the system to the redundant system. That is a requirement for.
Yes, yes. It is.
Otherwise, we can link 50 seconds also.
Yes, yes. Yes, yes. With respect to that only, I also got needed clarification, sir, because it depends on the subsequent, because it has got an impact on the subsequent stage. That is why I asked this. Another.
Actually, I would also like to add something in that.
Yeah.
Actually, we are saying based on the cycle time within 2 cycles. If the processor is idle for 90% of the time, in the same cycle it may switch over actually. It is within 2 cycles, it is not necessary that it will go to the 2 cycle always.
Okay.
It depends on how much the processor idle.
Okay.
Finally, to switch over, we have to detect the failure conditions.
Yes, yes.
If it is idle, it will detect the fast failure conditions, and then it may switch over to the same cycle actually.
Okay.
And failure is a random event. It can occur anytime actually.
Right. Right.
Last question, sir. What about seismic qualification of the PLC? Seismic qualification.
Yes, sir. Yeah, so it is seismically qualified, madam. Mechanical vibration test we have carried out long back, and recently one of the systems supplied to HSCMS with the similar engineering product, we got it qualified actually in the seismic by, I think, Iec river facility only it was used.
Okay. Because?
Yes. It is complied for seismic qualification because we are subjecting for IIIB.
Qualifications were projected. The seismic was not talked about. That's why.
Yes, sir. Yes, madam. Actually, yeah.
Okay, so it is done.
Yes.
It is along with the panel, and it will depend on the site also. So, yes, right. Additional mechanical, yeah, correct. That. Right.
Thank you, sir.
What is the global response time? And what are the diagnostic features for network failure?
It's not clear actually.
Global response time. For global contacts are used in this PLC? Global.
Sir, we have a inter-PLC module support is there where we can network our own PLCs. So,
yes.
So far we have tested 16 PLCs in our laboratory. And other PLCs through standard Modbus protocol and other protocol we can take global. And network, you have one more question on network failure, right, sir?
Yes, sir. Diagnostic features for network failure.
So the network is hard, the dual redundant network actually always. For SCADA interface in my presentation I covered. So it's a dual redundant network. It works on a single IP. In case of any physical failure in the medium, it switches over to the other network line available in the same module. In case if both are failed, then the system level switchover takes place. So since it is an active standby system, the standby will take over as a solo.
Okay.
Within 2 cycles, and these test cases are part of our evaluation committee. We have a test report. Maybe during our lab visit we can show those test records and all.
It is said that the system is having deterministic feature. Being Ethernet, how we say that it is deterministic?
So deterministic in the terms of the cycle time. If you suppose you set the cycle time of 20 milliseconds, we are always guaranteeing that the cycle time will be 20 only. It will not increase to 30 or 40. So we are maintaining that the cycle time will always be 20. Even if it goes to the 21 milliseconds, we are tripping the system actually. So we always say that the deterministic performance within the cycle time.
But whether it is ensured that the packet is reaching the desired destination?
Packet reaching.
Want to have the cycle time as 2 milliseconds. Impracticable, not possible. Because ultimately when you design something, you design with the parameters. And when you know this network traffic of 32 node RIOs, 32 RIO nodes with a master RF standby, so this is a well-known traffic. What is going to happen is that the RIO are not going to transmit on their own. See, if you understand the phenomenon of the network, if you allow the RIO to transmit synchronously on their own, then there is a possibility of collision, packet loss and all those things. So here what happens is, as he mentioned, it's a query response protocol. So RIO will transmit only when it gets the query. Okay, so that is one part. And also as he explained, how we have made the protocol, see if you go for TCP/IP, it has own problems. Because window size will vary, even if something happens in the switch, there will be some fluctuation in the window size, some retransmission can happen, then you get into jitter. So what we have done, we have gone for a UDP/IP based protocol, and that because that UDP/IP is ours only. UDP is very simple to write. If you write TCP, quite things are involved. but UDP IP you can write on your own. It's a query-based protocol. Also, what we do, we have a dual network. So every RIO sends the data twice. And as he explained, within a cycle, the RIO master is fetching the data, sending the query twice, and getting the data twice. So in fact, we get 4 times the packet in the same cycle. So possibility of any packet loss is 0. And then, as you said very rightly, we were also wanted to ensure that this is really working. And the secure PLC facility which is there, we have proven this. All such kinds of diagnostics we have put when we are continuously running on. And I am very proud to tell you that 0 packet loss.
So one more question.
So this is again the beauty of our in-house design. Now, if the same question, if we pose to, I won't take, any commercial PLC, the people who are coming for servicing or installation, they are not aware of these design features. So they are not able to answer so clearly, where we are very clear that yes, this is our design and it is going to meet. I hope I answered your question.
Sir, one more question. How input wire break is detected for contact inputs?
Yes, sir. Actually, we have additional overhead here actually. We need a resistor to be placed across the contact input actually, that is additional overhead. Otherwise, okay, it is not possible to detect for digital contact inputs. So wherever this, wherever this contact input is sensed, we need this additional resistor.
Parallel to the contact, we have to wire one resistor.
A small leakage current is required to sense it.
To that length only it will go to detect. Like if you put it very nearby, then you don't know. But you have to see that resistance you have to put as close as possible to the source. That is the standard practice followed everywhere.
Sir, again, Dr. Rajan from IPRC. Okay, that when we talk about this ECL particular PLC, okay, even though it is giving very, very good performance, we look like it is comparing other standard PLC or even PLC, it is very thick. It is not a common. But today, our madam finally miniature-wise they see presented whether this ISRO future requirement, whether it will meet.
No,
that miniature PLC.
Not very clear. A lot of echo is there. Can you talk a bit slowly?
Okay, when our PLC, okay,
keep the mic a bit away.
Keep it little faster.
Actually, when we discuss about PLC, okay, madam told, okay, she has developing that new miniature-wise PLC.
New?
Miniature.
PLC.
PLC.
I think in the last slide.
Yeah, I would like to know.
Because PLC, huge market. See what we are having, we have to also see the cost. See, everything comes at cost. Say, I don't want airbag, it comes less. So similarly, if you go as a customization exercise, that can be thought of.
Why I posted this question, our IPRC requirement, this number of IOs and things are going on because we are establishing very requirements. Our requirements in terms of IO nodes is going higher and higher.
Yeah.
So in future requirement, okay, we are coming to you only for developing with the higher nodes. That this integration with this rack concept, that will we can accommodate in a rack more number of IOs and all those things.
Sir, probably we can discuss during the tea. I think it is quite a lengthy question.
Okay, sir.
So maybe I think we'll be able to interpret better. But definitely we'll answer your question.
Actually, product engineering is a continuous process, sir. Actually, see what sir has asked is that last miniature PLC, they wanted to have more modules can be accommodated. So right now, that whatever the product we have shown, it is meant for RTO applications actually, less than 100, 200 IO count actually. So, and we are developing that as a diverse product for these some of the applications, low IO count applications, as a cost-effective solution, particularly in SCADA, RTU SCADA applications actually. And slowly, okay, this re-engineering, as we told, it's a continuous process. Definitely, we will look into such requirements in the future, sir.
Sir, one question. Actually, that your cycle time, 10 millisecond, is limited by, even though you have the high-speed processor inside, cycle time, the firmware only, I think it is a limiting factor there. Firmware, you are using codes, isn't it?
Yes.
Codes is back, or correct, sir. Okay, sir. Even that main CPU, that only main factor. So suppose if you are able to there control the timing, is it possible to bring down this 10 millisecond cycle time with even lesser than that? Because the requirement is, especially our satellite engines are operated in the on-orbit conditions, order of milliseconds, single digit, because in order to maintain the station keeping. So there, this PLC directly we cannot command it. Again, we are using another system because single digit millisecond only we need to operate the release. So if possible to bring down either using that software some complexity so that it will be very useful to the ISRO.
Yeah, there is an option, as we said, if you go for say Nikon S option. So in Nikon S option, there is no codices. And the ATOS is a very small footprint ATOS. So, the predecessors of this TPLC, there again based on the IO size and logic, we could achieve 5 millisecond cycle time on the CPU of TPLC, right? Now, if you say that this is your specific requirement, then depending on the amount of logics and all you are going to have, we can try it out this solution on Nikon S in that case, because 10 millisecond switchover cycle time limitation is coming from codices design. Now that's a black box that we cannot, we have no control on that. But if you have some specific things, then definitely you can try Nikon S.
Okay.
And again, there also what happens, if you want to have that switchover, then you can go for that dual redundant configuration with a switchover logic, like your outputs and all that. So a faster switchover can be guaranteed.
Why I have posted this question is, suppose that instead of using this code says, your own ECL makes some proprietary software. If you future planning is there,
Exactly.
it is well and good.
What is Nikon S is nothing but when we call Nikon series, now it's a DAE product. Okay, so whether it is Nikon C or Nikon S, it is ECL who is going to market. Okay, so Nikon S you can call. See, now I'll tell you, implementing 5 languages with everything, it's a very enormous task. And if you see function block diagram and ladder logic, they are basically type of application programming where you always say that it will execute from left to right, and you know that always if I logic of say 200 components in function block diagram, whatever be the process condition, it is always going to execute the same time. But the moment you go for structured text, sequential function charts and all that, in that case, the variation depending on the process conditions, the execution time will vary. So this is the limitation of 5 languages. That's why if you see IEC states for SIL 3 and SIL 4, they say that you go only for ladder and function block diagram. Okay. Now coming to implementation of these 5 languages, there are a lot of pros and cons. Now, for example, if you see many commercial PLCs or many of the commercial or industrial applications, what they want that one should be able to modify the application program online. Okay, that means they don't want the process to be stopped because it has impact on the economic impact. So they don't want process. So codices or most of the commercial PLCs, they allow you to modify the application software online. Even NRB also wants that, but they want it only during the commissioning phases. Now if you see Nikon S application in a nuclear reactor, whether it is safety system or safety related system, no point of time it will be allowed that on the fly you change the logic. So if you want to change the application software, you have to shut down the system, change the software and then restart the system. Okay, so these are the pros and cons. So it depends what you need, what are your safety requirements, what are your timing requirements. Then based on that, you see whether codices based type of thing is useful, because codices gives a lot of flexibility, but that comes with a penalty in the form of these kinds of things. I hope I could answer you. Mohit, you want to add anything?
No. Sir, I'm Rambabu from Mangur Heavy Water Plant, sir.
Yeah.
In that CPUC availability, you have mentioned that 1 out of 2 and 2 out of 3. 2 out of 3, we are all are aware, based on 2 majority, whatever is voting, that will be forwarded. In 1 out of 2, one will give one answer, another will give another answer. So which will be get forwarded, sir? Is it quite controversial, no?
1 out of 2, we will have a switchover logic based on the hardware relay outside the system.
Okay, sir.
So any failure in the one system, both the systems will generate the output, and that will go to the relay-based hardware logic system. The relay will be connected to one of the healthy system. If both are healthy, it will be connected to one of the healthy system. If one fail, the relay will switch over the output from another system to the field.
No. Which is the failure output? How you will confirm that? Which is the failure result?
Failure will be based on the WDT contact output. System health. That is system health.
System healthy signal generated from each.
All this will have a WDT contact output. That is a system health signal. If the watchdog time is overflow, the system is failed, and that contact will be used to switch over the relay.
That means one CPU fails, another CPU will come into service. That's all. That much only.
Right. Okay. That is fully redundant. Both are independent system actually. The system is completely independent, and both are doing their job. Both are computing the output, sending the output also.
Okay.
It is going to the relay-based module, where 2 outputs, one output is connected to the field, because both are healthy right now.
From both the CPUs, complementary output.
Contact will come, right. From both the CPU, the health. Yes. Right.
So in that case, watchdog timer failure it will see, and accordingly it will route the direction.
Right. That's correct.
Okay.
That's correct.
And these digital output modules. Digital output, normally this alarm tripping signal will never being used. We will maintain the plant such that never alarm signal has to come. But that output also never it will be coming, never it getting activated. Is there any provision to see any leakage current from the output in the low state also? It is intact, the total wiring is intact. Okay. So ensure that.
Output load open detection is already there, sir.
Already?
Output load open detection is already there.
In the low output state itself.
Actually, low output you mean?
Yes, low output
See,
state
actually,
itself,
when
I
state
should ensure that this is intact.
Yes, sir.
In the low output case, only the read back functionality is there. We are reading big time.
I should ensure total wiring.
No. That is
Sir, actually, we have a concept called fit test on the output module. Actually,
load open tak nahi jayega.
Load open tak. Okay. In low
It's not
output
there.
is sensing some
Okay.
leakage.
Sir, I have one question. This is related to the secure switch. Secure switch, which we have seen in one slide Vaidya sir has presented.
Security module, yes, sir.
Secure switch,
Systems,
network switch.
Okay, secure
so
switch.
what kind of layers it is supporting, layer 2, layer 3 switches, and the kind of protocols it is, the commercial protocols which are available on the switches? Okay, and whether we are using the switch here in the dual fiber link. Okay. Okay. We should have all the components secure, yeah. Yeah.
And it can create a DOS attack. Okay, so that means if you have a very distributed large INC network, and if you have commercial NTP, and for some reason it gets compromised, then your distributed system is at vulnerability.
Yeah,
okay.
yeah,
So secure NTP server is one of the things we have developed. So it is. I just told it for the audience to know that such things exist. Then data diode. See, data diode means what?
like one-way traffic
in nuclear safety systems, from lower class to higher class data should not go. Now you are having free network connectivity here and there. So what data diode does is a hardware device, hardware and combination of software. So it will ensure that even if the lower level system is trying to send the data to a system of higher category, there is no physical path exists. So it will get blocked. The design of the data diode is such that the reverse flow of information is blocked. No physical path is provided. So these are just principle of how data diode works. So I mentioned that in that context.
And what is the possibility that we can get these things?
They are available.
They are available.
No, see, all these products, data diode technology has been developed in BRC. It is being tested. See, normally if you see all the technologies that are developed in BRC, ultimately they come to ECIL as the product lines. This is our NTP server has been, secure NTP server has been tested in Dhruva. Okay, now by the time the INRP plants really comes up, there also they need NTP. So we'll be putting a secure NTP server there. Even NPCIL also now the secure NTP server we are testing in Tara lab. So, you know, they may say that they need some kind of further modification and all that. So we'll get that, and NTP server will be again, it will be product line of ECI.
So there is one sub question. Yeah. This NTP server is linking to the GPS network, or is it linking to the NAVIC?
It is?
Linking to GPS or linking to NAVIC?
Okay. See, it is what GPS, how you are interfacing. So as of now, whatever IC we are having, it is for GPS.
It is not available for NAVIC because ISRO was...
We have yet to get it. I mean, the moment we get it, we'll put it there.
Okay.
Yeah, good question.
Any more queries? We would be pleased to answer.
I have one more. I have a question. How relay output module take care of load activities during diagnostic scan?
Can you repeat, please?
Repeat.
Relay output module. How relay output module take care of load activities during diagnostic scan?
Load activities.
Load means if a load is active.
Okay.
Suppose from a relay module you have powered some power supply. Now at the time of diagnostic, what you said, you are switching these contacts and reading auxiliary contact for the diagnostic.
No, sir. And the relay output module, we are not switching the contacts.
You are not switching?
No. Relay output module, whatever is the output at that point of time, the second contact will be reverse of that. So if the contact output is NO, the second contact will be NC, and we will read that NC. So we have sent NO and we have read the NC, that's all.
Means you are not switching that?
We are not switching that.
OC fully, you have said?
Only
read back.
Only
read back. We are not switching in the case of the relay.
Means suppose a relay coil has been burnt. If relay doesn't operate, how you will be knowing that at the time of diagnostic, how you will know?
It will be read back only because that is a forcibly guided relay contacts. So if one is NO, another will be NC. That is the case.
Sir, myself Jitu from BRC Mysore. Sir, in this inter-PLC communication module, we have proprietary protocol, I understand. Can we have an open protocol there so that we can communicate to third-party PLCs also? Because that may be required.
Yes, sir. Third-party protocol. Yes, sir. Please. Please. No. Please.
Committee also whether this should be allowed on either. See, because otherwise what will happen? See, basically why you need inter-PLC company? There is a control system, dedicated control system for one process. There is a dedicated control system for another process. Now some fluid flows from this process to that process. So now there is a recipient tank in the second process. Now there are some interlocks on that. Now if that tank, those interlock of that tanks are controlled by that process control system. Now if the tank level goes high, it is reaching the alarm limit, then this control system has to inform the other control system कि आप उधर का wall बंद करिए.
Correct.
Okay, so this is the purpose of this. Now here the distances involved in that particular place, maybe, so you may have to route the cable 2 kilometers, 3 kilometers, because depending on the routing of the cables. Then whether to go for this or whether to go for wired one. So we felt that if we want to do this, then you must have a deterministic communication protocol, so that, because these inputs are used in the logics.
Okay.
So on a dual redundant network with deterministic communication protocol, we must be able to get it. So that is why we developed this proprietary protocol, ensuring that determinism will be ensured.
Okay, sir.
Yeah.
Sir, in that case, IO scanning feature is available with the processor?
What is that?
IO scanning. Normally, commercially available PLCs will have IO scanning feature. That processor can directly talk to the another processor using Modbus TCP.
IO scan in the sense...
IO scanning. Basically, it uses Modbus TCP. Processor itself is having that feature. Some of the available manufacturers, commercially available.
No, right now we don't have that higher scan feature, but maybe we can implement that.
Okay, sir.
So right now it's a single cycle time, single scan, sir, actually, and even multi-size scans also we are planning for some of the activities, upgradation.
Sir, is Modbus TCP master module readily available with the Nikon series right now?
Yes, sir. Yeah. Modbus TCP you want?
Master module?
Right now it is,
module.
as a slave, it is connected to the third-party HMI, and even Modbus master, serial master is available, TCP master is also available.
Also available. Again, as Behra sir told regarding implementation of HUD feature in AI modules, that would be really useful. You have any plan for developing such a module in immediate future?
Yes, sir. As part of Behra sir's presentation, it is already given that it is in our plan of development, HUD interfaces for analog input and analog output. And right now we are depending on the third-party gateways actually. Still there is a solution available.
Fine,
but
sir.
External to the system.
Okay, sir. Thank you.
Yeah, good evening, sir. First of all, thank you to ECL for developing the Made in India PLC, because we have seen Schneider PLC from France and ABB PLC from Switzerland, Siemens PLC from Germany, but Nikon PLC is made in India. So we can proudly say that it is Indian made. Ladder logic, FBD, and 5 types of logic. Is there any online conversion from ladder to FBD, FBD to STL?
Yes, sir. Our programming software supports actually.
It will convert. Okay, ma'am. Thank you.
Hello, sir. One of the requirements that while we were procuring your PLC was that for analog input module, there was no feature for input open. Like you have mentioned for thermocouple input card and all, there is a sensor open facility. So I think you said at that point of time you will be implementing that. So now we are entirely dependent on SCADA to know that the input is open. So whether you have actually implemented or you are about to implement, that I wanted to know. Like this 4 to 20 milliampere input, if the wire is open, how we will come to know?
So for analog input, madam, for current modules, naturally this input open feature is, naturally it is available. Depends on we have a feature called in programming configuration, this under voltage detection and over voltage, over range and under range detections are there. And user has the flexibility to configure these ranges according to his process requirements. Particularly even for voltage inputs also, right now it is addressed in that way actually. So like digital input, we don't have a specific wire break detection is not there, but for analog, we have a range of thresholds which a process engineer can set or user can set particularly. That's
okay.
Actually for voltage input, what we have, if you are using the full range of our ranges like 0 to 10 volt, then it is not possible to detect that. If you are using little bit less range, then I can detect the voltage open actually.
Any more queries, please?
Sir, I have one query that during PLC LAN communication, what type of spurious error may come?
Sorry, sir. One more. Repeat, please.
What type of spurious and say instantly errors may come during the LAN communication? PLC.
LAN communication?
During spurious errors.
Actually, for all these diagnostics, we are doing at 200 milliseconds, but we are also detecting that they are, the error is present consecutively for 2 cycles. Only we are declaring that the module or channel is faulty. So if any type of spurious error is there in that, it will get filtered out. And for all the input channels, we have a debounce filtering to filter out this spurious channel.
Yeah, that spurious error also we can observe in the communication like runtime bus error.
We are just filtering it out.
But so there is no chance to come.
We think so, sir. There is no chance to come.
Declare spurious errors.
Sir, in our list, sir, actually a CPU, a module with optical interface directly, it is in the pipeline actually. Yes. Inter-CPU communication, yes. Yes, sir.
So right now also you can go with optical, sir. We just need a media converter.
Yeah, right now the solution is given.
Just like convert from electrical to fiber optic at the active PLC level, and then fiber to that at the standby level.
Yes.
Right, sir. I agreeing with your question. Right now we don't have in this board actually direct fiber optic. That's why I'm saying that this we can manage with the optical converter.
Actually, in our previous PLC version, we had this option, sir, actually. That was not finding very much useful. That's why, okay, not considered. But anyway, we will maintain such modules also. It's not a very big deal. We will do that, sir. Yes, sir. You want one more port? Sure, sir. Yeah. Definitely, sir.
Right,
Yeah,
right.
in and around these development components, we are ready to take up any customization. Tomorrow.
Qualifying SCADA for IB, extremely difficult. Then the SCADA software will be sort of only embedded software. I will not put any operating system. See now, why we are graduating to Linux? See, tomorrow you will be having presentation on Linux SCADA. So we have moved from Windows to Linux is a one step towards that, because Linux is more secure. It is possible for you to make to harden the Linux. But then if you say that I want to qualify for safety class IB, then for the regulator to say that the code review of Linux is a big job. Okay, but then what you can do, because it's not mandatory, but then having a all design and it's very difficult. But at the same time, what you can do, as tomorrow one of the colleagues will be presenting on an Anunistha board which make the server trustworthy. So with such combinations, see there also in Anunistha he will be explaining you that how the Linux hardening is done. See all the system calls of Anunistha, they get routed through all Linux, they get routed through the Anunistha board. So indirectly we are making the Linux secure. Okay, and other part is that by developing all your GUI in Linux compared to Windows, that confidence of building building more secure thing comes up. So building it to IB will be very difficult. But what are the way outs? What way outs normally, see, because even if you see in our NPPs, many of the systems earlier were connected on Windows system, IB system is Windows. Then how do? You say that whatever, now what are the possibilities of this Windows SCADA causing some problem in my safety class IB system? Possibility comes in, normally it's only a one-way traffic. If I'm missing SCADA only for dumping, I can always put the data diode and there is no issue, IC will do. The problem comes that when I need to send some command from the SCADA workstation to the embedded system. Okay, now there are different type of commands. One type of command is soft consoles. Now the trend is that replace the hard panels in the control room with soft panels. Now there commands will go, so there is no question of echo back and all that, no password. Command will go and it will execute. So in there, this communication protocol, what you are implementing for sending the command to the embedded system, at least that should be fully under your control. Again, commercial SCADA, that is not there. Now I will tell you the example of this. In Kudankulam NPP, soft consoles are implemented left and right. But there, this SCADA is entirely developed by the Russians. The Linux is also developed by them, R&D organization. So they have developed this Linux. This Linux they have fine-tuned to a particular processor and very tightly coupled with that. And they showed us all the documents. There, if I want to change the set point, now set point changing is some protocol. So if I'm changing a set, so second time you say confirm 150 will not be your algorithm. So that is what I am saying. Correct. So, but then this protocol, see, where OS can malfunction? Through this protocol only. Okay.
Sir, I am Riju from NBCL. How the floating point errors are handled in CPU, PLC CPU? Underflow, overflow.
Sir, sorry, sir. Could you please repeat?
How floating point error is handled in PLC? Underflow error can occur, overflow error can occur. Like divide by 0 happens, what PLC will do? So it will halt or...
Sir, your query is because of my clarity, we are unable to hear.
Say there is a divide operation.
Exceptions and floating point errors.
Floating point, already the exceptions have been implemented actually. So any floating point error, the exception will come, and based on that, we will either trip or halt the system, switch over to the another system. It is as per the IEEE actually. We are not making any comparisons with the floating point. We are not doing anything on that. And wherever the division comes, we are always checking that it is not 0, it is greater than 0. So those all checks we have done in the code actually. So wherever division is there, wherever comparison there, we are always making sure that we are not comparing the direct floating point numbers. We have one threshold parameter with which we are comparing. And for the division also, we are making sure that there is, but anyway, divide by 0, floating point exceptions, those all exceptions we have implemented in the code.
In programming software IDE also, she means run.
Thank you, sir. That was quite interactive. Thank you everyone for being part of this grandeur launch of Nikon PLC and SCADA. Hope you have found the technical presentations fruitful and engaging. We would be having few more such sessions tomorrow. So before we call it a day, let us all rise in reverence for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai Hind. I request all of you to savor tea and snacks before leaving the auditorium. And guests who have commuted by buses arranged by ECIL, the buses are available outside the